Yeah, started.
Yes.
Yeah, we can start, I think, sir.
Okay.
Sir,
Yes.
ನೀವು ರೆಡಿ ಇದ್ದೀರಾ? ನಿಮ್ದೇನು ಕೆಲಸ ಇದೆಯಾ ಸ್ವಲ್ಪ?
ಆಯ್ತಾಯ್ತು.
ಅದು ಸರ್.
Okay. Shall we begin, sir?
Yes, madam. Please go ahead.
Good morning. I'm Shweta Dalvi, the Internal Quality Assurance Cell, GSS College, Belgavi. Welcomes everyone to this online guest lecture on the topic, How to Think Like a Scientist. Our guest speaker for today is a renowned scientist, Professor S.M. Shivprasad. We are happy to have staff and students of GSS PUC, BSc, BCA, and MSc courses. Scientist thinking means embracing curiosity. Scientists ask questions about things, they make observations, they set up hypotheses, and they conduct tests to draw conclusions. This method is called as scientific method. To encourage our young students to develop inquisitiveness and to find solution to their lot of unanswered questions, we have organized this guest lecture on the topic, How to Think Like a Scientist. To start the program, I request our principal, Dr. N.D. Hegde sir, to welcome everyone to this session.
Thank you, ma'am. Good morning, everybody. Distinguished speaker, Professor Shivprasad, Director, Higher Education Academy, my colleagues, and my dear student friends. It gives me immense pleasure to welcome one of the most distinguished professors, a renowned scientist, an orator par excellence, and presently the director of Karnataka State Higher Education Academy, Dharwad. In fact, I was planning to get sir onto our campus to talk to our UG and PG students in person, face to face. This idea, in fact, I had when he had come here to address our PU students during the Inspire internship program in September 2018. I had requested him also, and he had agreed to address our students. But due to the prevailing pandemic and several other issues, since March 2020, we have not been able to meet in person, even with our students on the campus. It has become really, really tough. Okay. So somehow that remained as it was. And then in the last week, I spoke to sir whether we can have an online talk to our students. Okay. Then he readily accepted our invitation, actually. And then he said, we can have it maybe very soon. And we fixed the date to be on. Initially, it was on the 30th, since we had some examinations to be conducted. I requested him to prepone, and he said 24th is okay. And in the meantime, maybe last Saturday or Sunday, I got the message that he has been nominated by the Karnataka state government as a member of a committee constituted for the implementation of NEP 2020 from the next academic year itself. And the last date given was 30th of June. So in fact, I was a little apprehensive whether Sal will be able to continue with this program in his busy schedule. This is another responsibility given to him, and that too in the very short time he is supposed to present the report to the government. But as the saying goes, busy men always find time for everything. So he is with us, managing to find time to spare with us some more time for this particular talk on how to think like a scientist. I'm extremely happy that he has obliged and he is here with us. And so on behalf of Govindaram Seksaria Science College and on my own behalf, I extend a very, very warm welcome to Professor Shivprasad. At the same time, I take this time to welcome all my colleagues and the students, and also those who have logged on to Zoom or YouTube link to listen to Professor Prasad. Once again, welcome you all. I take leave of you. Thank you. Thank you so much.
Thank you, sir. I request Dr. Anuja Naik to introduce our today's guest speaker.
Unmute, madam.
Am I audible, sir?
Yeah.
Yes.
Yes.
Unmute, madam.
Again, it is muted, huh? Yeah.
A very good morning to you all. Respected faculty members, dignitaries, and student friends. We are honored to have an eminent scientist, Professor S.M. Shivprasad, as the guest speaker for this special lecture, and it's my proud privilege to introduce him to you all. Having gone through the impressive CV of Professor S.M. Shivprasad, which reflects a long list of academic accomplishments and a volume of recognitions and accolades that he has received, I realized that it isn't an easy task to introduce him within a short time. Indeed, I was baffled to decide what is to be mentioned and what is not. In fact, everything about Professor Shiv Prasad needs to be mentioned, and therefore, here is a modest attempt to introduce him as briefly as I can. Professor S.M. Shivprasad is currently the director of Karnataka State Higher Education Academy at Dharwad. He is also a senior scientist and professor at the Jawaharlal Nehru Center for Advanced Scientific Research, that is JNCASR, Bengaluru. He obtained his PhD in thin film physics from Karnataka University, Dharwad, and pursued postdoctoral research at IIT Delhi and later at the University of Sussex, United Kingdom, as a Commonwealth postdoctoral fellow. He has been conferred with the prestigious DSE from VSK University, Bellary.
Sorry.
Before he joined JNCASR, Professor Shivprasad was the chief scientist at the National Physical Laboratory, New Delhi, for 2 decades. He has been also a visiting scientist at the National Institute of Standards and Technology, Maryland, USA, at Rutgers University, New Jersey, USA, Tohoku University, Japan, and the University of Ulm, Germany. A scholar of high repute, Professor Shiv Prasad has published 286 research papers in international journals, 23 in national journals, and 240 presentations in national and international conferences, and 514 invited talks to his credit. He has authored 2 books and edited 1, and all these achievements speak volumes about his extraordinary scholarship. His research interests are thin films and the nanostructures of semiconductors. As an academician, he has been striving hard to promote high quality in higher education institutions in Karnataka by designing and implementing best practices through faculty training programs. Professor Shivprasad has been the Indian representative to the International Union for Vacuum Science Technology Applications, USA, World Materials Research Institute Forum, Japan, Euro-India Cooperation for Nanotechnology, and Euro-Brazil Cooperation for Science. He is the Vice President of the Materials Research Society of India and holds many more prestigious positions and memberships of many professional bodies. Such outstanding accomplishments are befittingly recognized, and Professor Shiv Prasad has been conferred with many prestigious awards. He is the recipient of the Young Scientist Award from the President of India, CNR Rao Oration Award, Dr. Raja Ramanna Senior Scientist Award from Government of Karnataka, and Outstanding Award from CSIR, and the list goes on. I have tried to mention only the outstanding awards. Yet another feather in the cap of Professor Shiv Prasad is the fact that he has been, as Principal Sir mentioned, he has been recently nominated as a member of the Committee for National Education Policy by the central government. We are truly fortunate to get an opportunity to listen to such an illustrious scientist and a scholar. And with this brief introduction, as brief as possible, I present to you all today's guest speaker, Professor S.M. Shivprasad. Thank you so much.
Thank you, ma'am. May I now request the guest speaker to take over and address our students.
Okay. Good morning, all. And thank you, Hegde sir. Nagaraj Hegde, my old friend. Old
Thank you,
means
sir.
he's young, but I am old. So, but he's my friend for a long time. Okay. And Pramod sir and Shweta madam. Okay, for giving me this opportunity. I'm grateful to Anuja Naik madam because she made me look better than what I am. Thank you, madam, for making me look sensible. I'm not as sensible as you have mentioned, but anyway, some effort in my life. Before I wanted to speak to everybody, again, let me request all of you to switch on your videos. Without seeing your face, request as many as possible. And unless you are in a presentable shape, if you're not presentable, it's okay. But otherwise, please switch on your videos. Thank you, Afreen madam. Thank you very much. Okay, Sharwari Desai. Okay, yeah. My daughter's name is Sharwani, so I was very curious about you, sir, to see who you are. Okay, okay, Patil sir. Thank you all of you, because and it's very difficult for a teacher, right? You all realize, most of you look to be teachers. It's very difficult to see without looking into the eyes of the students, right?
Yes,
So
sir.
you need to understand the emotions, the understanding of the student, and that is how we get the energy. The teacher gets the energy by looking at the eyes of the students. And I mean, I'm treating you for a while. Please excuse me for this. I'm treating you for a while like students. So, but I'm sure I'm actually addressing the students. Hegde sir, Nagaraj Hegde sir was mentioning that he has made time for us. You know, it's a very big word. Okay, it's not true, because my priority is always students. So all the chief minister and prime minister can wait, but students are very, very important for me. So I would not shift anything for my commitment when I commit for the students. Everything else can wait. So
Thank
I
you,
request
sir.
all the teachers also to give that priority, because sometimes I keep hearing teachers telling, sir, I wanted to teach a class, because now I deal with teachers. So I've heard a lot of stories. They say, but principal tells me, class is to. So I think that should not happen. Our priority is students. Our priority is education. NACO, NEP, these are all side businesses, right? We do that. So with that spirit, I would like to say that students are very important. Why students are important? At the end of the talk, I'll tell you, because if teachers had interacted with me very well, okay, I would have not been an ordinary scientist like Anuja madam said. I would have become a Nobel laureate and sitting here. So my intention here is to tell many things to the young students so that each of them becomes a Nobel laureate. Okay, that is my intention of what I'm, because I know now, interacting with students and teachers, we are all much more capable than what we think we are. We are much more. Their potential is there. We start telling that fellow is smart, this fellow is not. Nothing like that. Each of us are smart. We have just not we have not been just motivated to do that and bring the best out of us. And that's what I have learned in my old age, and I would like to share that with all my young friends here. Of course, everybody here is younger than me, so it's okay. I can call you as all as young friends. Okay, friends, what I'll do is I'll start sharing my slide. Another small problem I have, I hope you'll bear with me. I have a serious problem, because I know when to start, but I don't know when to end. So usually I go on and on and on until everybody walks out of this group. So don't worry. If you feel terribly bored, you can always switch off your videos and walk out. So that, don't worry about that, because I have a problem I don't have brakes in my car. I just know I have a starter, but I don't have a brake in my car. So it goes on and on. So let's see. It will all depend on the interaction. As I said, that when I look into your eyes, the kind of reactions will decide how long we go along. So please excuse me. I'll share my slides. Okay, start sharing. Okay, are my slides clear?
Yes, sir.
Yeah,
Clear.
very good. Okay, so the topic I've chosen is something very strange, right? How to think a scientist. I am a very ordinary scientist, but I know how big scientists think, because I have an opportunity to work with very many big scientists and how they think. So we'll look at this is very important because I just want to tell you that scientists are not out of the world. They are also born like us only. Our appa amma tap made avaru huttara. Okay, so we should understand that everybody is the same. And when they were children, nobody knew that they are going to get a Nobel Prize anyway, right? So everybody was like all of us, but some of them become different with time. And that's what he said, because they learn how to think in a different way. So I keep telling my teachers, friends, that our students should not become alcoholics. They should not become even workaholics, but they should become thinkaholics, right? How to make people think is the most important thing for every teacher, and for every student to learn is how to think that I can think. Okay, that is the responsibility of every teacher. So thinking is more important than anything. Unfortunately, our good students means they become workaholics. Okay, once you become workaholics, you cannot become a good thinker, right? Because you try to only remember things. You're not able to think something. And that's what I want to share. There is no need for you to work very hard. You just have to think all the time. So you can see here, when you say scientist is thinking, you look at this thing. We think that, oh, so many things are happening in our mind. Look at that equation, look at that microscope, look at that, this, I mean, all sorts of things. It gets very scary, right? But the real scientist is not the person who has all these equations in his mind, but this particular picture. You see the left side, that beautiful girl, very cute girl with very blue, beautiful eyes, actually very curious. You know why the eyes have opened? Because she is seeing something, very curiosity. Just now, Sweta madam said that scientists are driven by curiosity. Okay, curiosity is the main thing. All of us are curious. Okay, we are curious about everything, something or the other. Like when you grow up, you become curious. Why are the husband and wife in the neighbor's house fighting? So that is also a curiosity, kind of curiosity. But when you're young, your curiosity is much more natural. You look at the nature, look at beauty of the nature, and become curious about nature and beauty. And that's what this girl is doing. She's looking at that beautiful flower. We all know we would see this flower, tramp on it and walk away. But here there's a girl opening her eyes and saying, my God, it's so beautiful. Okay, I think that's very important. And then you can see here, this side, right side, is the person who actually proved what curiosity is all about. Probably the greatest scientist ever born in this universe, Albert Einstein, who was, you all know, he was a terrible student, right? He was a terrible student, but he became the greatest scientist. How did a terrible student become a great scientist is a big question which we all need to ponder and start realizing. If you are a terrible student, you have a great opportunity of becoming a scientist. If you are a good student, then also you have an opportunity to become an Einstein. So I think, again, Einstein says here, imagination is more important than knowledge. Please understand, our education is about making children imagine things. It is not about giving knowledge. So he says, for knowledge is limited to all we know and we understand. Right? Knowledge is only about already what we know, what the teacher has taught, what is in the syllabus, what we have read, what people have seen. That is knowledge. But curiosity is about something, imagination embraces the entire world, and all there ever will be ever to know and understand. Something which you don't understand, you become curious about, right? I think that is very, very important. This message, I think, is the most important message of what Einstein says, that imagination is more important than knowledge. Okay, friends, what do we mean by this? So let's think about it. Before that, let's do a small definition. It's always clear to understand what is definition. Let's understand what is science, what is technology, and what is engineering. Somehow we mix some of the things, we start mixing everywhere. We call IT as a technology, okay? We call it as a science also. We mix up everything. Engineering is science, technology, engineering. We don't know, we are confused. But actually, as students of science, we should understand that there are three distinct features. Science is different from technology. Technology is different from engineering. Science is about discovery, okay, of discovering something. Science about understanding, imagining about something. And with the question, and it's driven by the question why. Always a scientist keeps asking this one important question in the mind is to why. In Dharwad Kannada, it is yaka, right? Yaka anta kelkondu hogudaitala, I think is a terribly, terribly important thing. ಯಾರು ಯಾಕಂತ ಕೇಳ್ಕೊಂಡು ಹೋಗ್ತಾರ, ಅವರು ಡಿಸ್ಕವರಿ ಮಾಡ್ತಾರ, ಅವರು ಸೈಂಟಿಸ್ಟ್ ಆಗ್ತಾರ, ಅವರು ಸೈನ್ಸ್ ಮಾಡ್ತಾರ. It is not necessary that every scientist has to discover something. But the whole process, as we see along, as the whole process that is what science is all about. Science is about asking this question, why? Then technology is about invention, innovation. A technologist is taking the ideas of a scientist, okay, and then putting together to make something useful, right? He'll put everything together and make a pen. And the scientist cannot make a pen. He can only tell the capillary action of ink. He can talk about the polymer, the property of a polymer, etc. But he doesn't know how to make a pen. Okay, the scientist cannot make a pen. A technologist doesn't understand what is the electron, photon, phonon, etc. But he understands how to make a pen from the graphs and from the graphs and the equations which the scientist has derived. And that is a technologist. But ultimately, somebody has to make the product, right? So technologist has thought about a product that it can be done by using this phenomenon. But ultimately, somebody who is making a product is called as an engineer, right? So engineer improvises the knowledge. Okay, he improvises the knowledge by asking the question what. Not that scientists will ask only the question why. He will also ask how, why, what, where, etc. And technologists will also ask other questions. Engineer will also ask questions. But the primary question, if you want to do that, is these particular three questions. So now let's see. When we say this, let me make it a little bit clear for the students. Now, what do I mean by the scientist? See, look, these are the pictures of scientists. You all know who these people are. I have not written the name, so I'll give you 5 seconds to think who these 4 people are. The one on the left top, then the lady on the right side, and these are 2 very, very well-known scientists. Okay, just think about it: Albert Einstein and Madame Curie. And in the bottom, we have 2 great Indian scientists. Okay, one on the left side is Professor C.V. Raman, and the one on the right side is a living scientist, a living legend, okay, who is Professor C.N.R. Rao, Bharat Ratna, Professor C.N.R. Rao, whom I have the opportunity to be working with every day. Okay, these are examples of scientists. See, these scientists are not making a pen or a solar energy or something. They are not doing anything. They are just curious to find out how things happen, how nature is there. Can I manipulate nature? This is the question what scientists are driven. But then you have these people, Thomas Edison, Alexander Graham Bell, Tesla, Benjamin Franklin. These are all technologists, right? They have found the concepts of, they have not found out any phenomena of science, but they've used the phenomena. Of course, Edison is an exception because he has done a lot of amazing science also. But I won't go into the details. You know that Edison probably would have not got about 10 Nobel Prizes. I think Thomas Alva Edison was like that. But let us say Alexander. So these are technologists. They made something use of this kind of technology, and that is why they are technologists. Now, who are engineers? For the popular view, these are 2 great engineers India had produced. One is, of course, C.V. Raman, and the other is an engineer, teacher, nice human being, everybody, Abdul Kalam. Okay, I had also an opportunity to work with Abdul Kalam, and that is wonderful. That's how I've learned with all these wonderful people. But we confuse. Sometimes the common man says Abdul Kalam is a scientist, right? But he's not a scientist. For the common man, he's a scientist. But for students of science, he's an engineer. He's an extraordinary engineer. M.B. Vishwesvaraya is an extraordinary engineer, but they're not scientists. So let's understand this distinction. That is very important, because later, when you want to choose your career or anything of that sort, or what you want to become, you need to understand this difference. Because now you are students of science, future you have to select between becoming a scientist, becoming a technologist, and becoming an engineer. Now, scientist is somebody, okay, who is working very hard without knowing what he is doing. If he knows what he is doing, he's not a scientist, right? Because he is trying to find out something which he doesn't know out of curiosity. A technologist is trying to find out to make a thing using the knowledge of scientists to make something and to make useful something useful. And engineer exactly knows what it is, but he knows how to make it beautiful, how to make it reliable, how to make it work, how to make it cheap, how to make it aesthetic. This is the challenging for an engineer. All 3 are important professions. Okay, none of them are less important than the other. But one thing we should remember, that the first top one is always the science. The knowledge comes from the science, So science is the basis of everything else. That I think is very important to understand. Okay, let's go ahead with this definition. Hopefully you understand the difference between science, technology, engineering. If you have some questions, I'll give you my email ID at the end. I'll be very happy to interact with people who have different questions, who might doubt something. And whatever, let me also tell you, okay, whatever I say may not be correct at all. It is my stupid thinking. Okay, so I may be absolutely wrong, and you have the right to tell me and contest with me and say, sir, saak bidri, bhal bogus baat matadakatiri. So you have the right to say that. But right now you don't have the opportunity because you have to allow me to speak. But you can always put it in my email or in the chat box. Okay, I may or may not be able to see in the chat box, but it's very important for you to say, to think on your own, and don't accept because I say it. Because, Anuja madam said that Shivprasad is a very big scientist. Don't believe me. Don't believe anybody. The characteristic of a science is don't believe anybody. You have to be convinced in whatever it is, and that is what the most important parameter or the characteristic of a scientist, right? So don't believe me, but listen to me. That is very important. Okay. Now this is the question. So there are what I told you is everything starts with curiosity. And the curiosity leads to observation, right? Just being curious doesn't help. Once you are curious, then you have to observe something very, very carefully. Then small questions start coming into your mind about that observation, right? You will start asking, why is this? What is this? Where is this? When is this? How is this? Okay, these are the questions. So they show you different directions, as you can see. The tiny questions, ultimately, then you start making an evaluation. Imagine those questions which you have asked, and then try to find out whether it is right, my question is right or wrong. So the question, every wrong questions brings you a new question, and every new right question does not bring you a question. That's why I want to tell you very importantly, failures are more important to become a scientist than successes. So, because always a failure brings out the better question in all of us. So always look for failures. I'll show you some of the comments made by Einstein. Okay, what are the successful things, how he became successful? I'll show that will be my last slide or penultimate slide where he will tell you. So please understand, failures are very, very important in one's life. We always get disappointed with failures. Fail ade nanu, PUC fail ade. Nin punya adu fail agide anteli, because you have an opportunity to think about it. There was once a time when my daughter was not doing very well in examination. We were in Delhi at that time. My daughter was very young in school. She was not at all concentrating in studies like all of us at some stage of her life. She was not studying. Then my father was a professor in the university. Okay, he visited us in Delhi, and we visited. Then we told her, you guide her, you advise her. Right, we want to take a big man and show that you guide her and advise her. So we asked my father to advise. My father advised. Okay, I'll tell it in Kannada. It's a little bit more interesting the way he spoke. I would like to tell it in the same way. He said he told my daughter, Sharu, nee chinti madbada. ನಾನು ಶಾಣೆ ಅಂತ ತಿಳ್ಕೊಂಡು PUC ಸೈನ್ಸ್ ತಗೊಂಡಿದ್ದೆ, 3 ಸರ್ತಿ ಲಗ ಹೊಡೆದೆ. Okay, I failed 3 times in PUC in science. Then ಆ ಟೈಮ್ನಾಗ ನನಗೆ ಊಟಕ್ಕೆ ರೊಕ್ಕ ಇದ್ದಿದ್ದಿಲ್ಲ, ಯಾರ್ದೋ ಮನೆಗೆ ಕೆಲಸ ಮಾಡ್ತಿದ್ದೆ. ಆ ಕೆಲಸ ಮಾಡ್ತಿದ್ದಾಗ ಅವ್ರ ಮನೆಗೆ ಬುಕ್ಸ್ ಭಾಳ ಇದ್ವು, ಸಾಹಿತ್ಯದ ಬುಕ್ಸ್ ಭಾಳ ಇದ್ವು. ಓಕೆ, ಆ ಕೆಲಸ ಕಸ ಹೊಡ್ಕೊಂತ ಬುಕ್ಸ್ ಓದಕ್ಕೆ ಶುರು ಮಾಡಿದೆ, ಸಾಹಿತ್ಯದ ಬುಕ್ಸ್ ಓದ್ ಮಾಡಿದೆ. ಅದು ಮಾಡಿದ ಮ್ಯಾಗ ನನಗೆ ಸಾಹಿತ್ಯದಾಗ ಇಂಟ್ರೆಸ್ಟ್ ಬಂದು ನಾ ಸಾಹಿತ್ಯ ಆದೆ ಅಂತ ಹೇಳಿದ್ರು. ಅದಕ್ಕೆ ಅವ್ರು ಏನಂದ್ರು, ನೀನು 3 ಸರ್ತಿ ಲಗ ಹೊಡಿ, ಓಕೆ, ಫೇಲ್ ಆಗು, ವಿಚಾರ ಮಾಡಿ ನಿನಗೇನು ಸೇರ್ತೈತೆ ಅಂತ ವಿಚಾರ ಮಾಡು, ಅದನ್ನೇ ನೀ ಮಾಡು, ನೀವು ಅದ್ಭುತ ಆಗ್ತಿ ಅಂತ ಹೇಳಿದ್ರು. ನಾವು ಯಾಕಾರ ನಮ್ಮ ಅಪ್ಪನ ಕರ್ಕೊಂಡ್ ಬಂದಿಪ್ಪ ಅದಕ್ಕೆ ಕೇಳ್ಸಾಕಂತ ವಿ ವರ್ ವರಿಡ್ ಅಬೌಟ್ ದಟ್. But later now I realize, as my hair also grayed, okay, I realized that was a very fantastic advice he gave. Right? Please think, all of you friends, failure is the sure road to success. Failure, your success doesn't lead to you to make bigger success. It saturates you very soon in life. You success ಆಗಿ ಎಲ್ಲಾದ್ರೂ ನೀವು ಫಸ್ಟ್ ರ್ಯಾಂಕ್ ತಗೊಂಡು ಹೋಗ್ಬಿಡ್ರಿ, you will become another software engineer in Infosys. ಆ ಮುಂದೆ ಬೆಳೆಯಂಗಿಲ್ಲ ನೀವು. Okay, but you fail ಆದವ್ರು ನೋಡ್ರಿ, you can become a great scientist, you can become a great innovator. So you look at all the stories, all the great innovators or scientists ನೀವು ನೋಡ್ರಿ are people who failed in their studies and people who gave up the studies in between. You remember all these Bill Gates, Jack Ma, I mean, all the stories you take them, they're all people who failed in life. Please understand. So failure is a great boon to our lives. Okay, failure is not only examination, in anything we try. I try to do something today, I'm trying to give a talk, I may fail. And when I fail, I'll actually learn what I should do better next time. So that's why failures are very, very important, my friends. So don't worry about this. Life is not about competition. It is not about examinations. There is something much more beautiful in life. Okay, it will come later stages in your life. You will see those beautiful things. So enjoy life. I think that is very important. So these are the questions. So you have this curiosity, which leads to observations, which generate small questions in you. Don't stop asking those questions or trying to find answers for these questions. Then you start imagining answers for these questions, and then ultimately you will find the big answers. It is only a matter of time when you find the big answers. And that is the attitude how to become a scientist. Right. Now, friends, I have this beautiful video which inspires me to become a scientist, which inspired me. A couple of things which inspired me to become a scientist is one, this video. Of course, this video is very recent, but the spirit of this I'll show you later. This is what I got in a WhatsApp, in my WhatsApp, this one. Just watch this video for 2 minutes. See what I want to watch, if you can see it very carefully. See the scale bar in the bottom. There is a beautiful girl lying on the lawns of the Google, in the lawns of Google in Washington, in America, and she's dying. And you look at the scale bar here, it shows 10 centimeters, right? I'm sure you can see the scale bar, but anyway, I'll keep telling it also in case you are watching with the mobile phone, you may not be able to see the scale bar. You just watch this girl. Okay, we all love watching girls. All the boys love watching girls. Let's watch her also. Alendra, sir. Yeah, very important.
Yes.
Okay. Yeah. Okay, so let's watch this. Let's go ahead and watch this girl. Now what we do, I go far away, 1 meter. Now the scale bar is changed to 1 meter. Now it is 10 meters, 100 meters, 1 kilometer. From 1 kilometer away, you are looking at it. Now it's 10 kilometers, 100 kilometers, 1,000 kilometers, 10,000 kilometers, 100,000 kilometers, 1 million kilometers, 10 million kilometers, 100 million kilometers. See, from such far away, we know how the world looks like. 10 billion kilometers, 10 billion kilometers. And then we come to 1 trillion kilometers, which is about 1 light year. And then I start seeing it 10 light years, 100 light years, 1,000 light years, 10,000 light years. You see, I see the galaxy, 1 million light years. Amazing, right? 10 million light years, 100 million light years. Look at this cosmic web we know about. It's a 10 billion light years, my friends. This is all we know with our knowledge. We know about 10 billion light year scale we can see. Now let's go back. You see this world very fast. We'll return 1,000 light years, 100 light years, 10 light years, 1 light year, 1 trillion kilometers, 100 billion, 10 billion kilometers, 1 billion kilometer, okay, 10 billion kilometers, 100,000 kilometers, 1,000 kilometers, 10 kilometers, 1 kilometer, 100 kilometers, 10 meters, and that beautiful girl, 1 meter. Now let's start seeing into her eyes. Now let's go deep inside her eyes. 1 centimeter scale, 1 millimeter, 100 micrometers, 10 micrometers, 1 micrometer. You start seeing the DNA, right? Look at the DNA, 100 nanometer scale. Then 10 nanometers. So we start looking at the structure inside a DNA, 1 nanometer. Then we have 100 picometers. Start seeing atoms, right? 110 picometers. Then we get into the nucleus at less than 100 femtometers. We start seeing the nucleus. 10 femtometers. Look at inside all the beautiful things inside a nucleus. 1 femtometer, we look at a quark. And then we come back. Of course, there are string theory, which has come. Okay, let me stop here, my friends. You look at this beautiful girl, how complex she is. Each of us are complex like this. And look at the range science been able to see, right? You saw those huge cosmic network, and then you ended up with quarks. Now you have something more called as a string theory. Now you start looking at strings as the most fundamental particles. It's no longer the quarks. So there is so many beautiful things just by done this stupid 5 feet, 6 feet old person. Okay, boy or girl, the whole scientists brought about this kind of amazing knowledge, right? So let's look at it. Look at this person, okay, who is sitting here with his wife. Anybody knows who he is? Okay, you may not know because he looks like any of us. ಅದಲ್ಲ ಈಗ ನಮ್ಮ ಪ್ರಮೋದ್ ಸರ್ ಸೂಟ್ ಹಾಕೊಂಡ್ರೆ ಹಿಂಗೆ ಕಾಣ್ತಾರೆ. So everybody looks like that. Everybody is a common man and his wife is also a common lady, drinking the same thing, eating the same thing we have. And let's look who he is. He is S. Chandrasekhar, who got the Nobel Prize in 1983 for what is called finding out the life cycle of a star. Right? There's something named as Chandrasekhar limit. You know that. See, when the stars, what happened to the stars when the size of the stars becomes so much, etc. Amazing contribution from Chandrasekhar. He was also the nephew of C.V. Raman. Okay, amazing Chandrasekhar. 1980 got the Nobel Prize. You all know, wonderful. What happened to the Nobel Prize in 2020 was got by these three wonderful people: Roger Penrose, Andrea Ghez, and R. Genzel. These are the people who got for understanding the black hole, right? So look at the black hole. It was such a black hole. No information comes out of that black hole. That's why we could not understand black hole. But this was the first picture, 2019. They took the first picture of a black hole. This picture is there. That was done by Andre Ghez and Genzel. And of course, Roger Penrose was been talking about the black holes for a long time. So all the three together were given the Nobel Prize of 2020. These are amazing people. These are the scientists who motivate all of us. Right? And because they were just so great because they were cycle. I mean, they were curious. Right, friends? Now let's go to the next star. This is one picture which motivated me when I was in college. Okay, when I was in college, like you, like the students like you, I used to go to the library for a different reason. I used to go to the library to look at all the very beautiful girls who were studying there, because most of the beautiful girls were sitting in the library and studying. So we used to go to the college there. So one day when I was entering the library in Karnataka University, Dharwad, the university library, okay, they had put this picture outside. Okay, this picture was there. It caught my attention so much that I stopped seeing the girls after this picture. So this picture was much more beautiful than all the beautiful things I thought were actually beautiful in life. Yeah. Earlier, we used to think that only some things are beautiful. Then I realized this picture is so beautiful. You know what is this picture? Everybody has seen this picture. So what is beautiful? Okay, is this point. It had written on top of this, the Milky Way is somewhere here. And I just studied about the Milky Way. And in this universe, they say the whole Milky Way, in which our whole Earth is a small part, they say is somewhere here. You can't even locate. That created that interest in me to tell, my God, knowledge is so much more beautiful than what we think, what we see in everyday life. We end up seeing some small things and calling it beautiful. But later, when we know that the world is so much more beautiful, our concept of beauty changes. When your concept of beauty changes, that is when you become a scientist, right? All the common man sees common things as beautiful. Common things is beautiful. A flower is beautiful. The face is beautiful. The girl is beautiful. The boy is beautiful. Everything we see. But ultimately, when you mature enough to start thinking, there is something much more beautiful. We'll talk about this beauty also a little bit later. This is related to the golden mean and the Fibonacci numbers. We'll talk about this. Beauty also has some beautiful mathematics in it. Okay, mathematics is beautiful. When I was a student, I never realized mathematics was beautiful. Okay, even the beautiful mathematics teacher also looked ugly to me because I could not understand mathematics. Right? All of us struggled with mathematics to understand mathematics. But again, when my hairs became gray, I started understanding mathematics. I also passed. I also got numbers. I got marks, medals, everything. But I did not understand mathematics and physics. That is the beauty of our education system, that without understanding, you can get a gold medal in physics, and without understanding, you can get a gold medal in mathematics. That is so beautiful, right? It's so, okay, you can do that. But later you realize there is something else I've missed in my education. Right? There is something more beautiful which I've missed in my education. to realize that, and that's what it is. So this picture motivated us when you look at the universe and start thinking, my God, where are we? Who are we? The same feeling. So again, you look at the Milky Way. Inside the Milky Way, our solar system is somewhere. Okay, inside the whole huge Milky Way, you see the scale, 26,000 light years is the size of our Milky Way. And in that Milky Way, our solar system is somewhere else, somewhere small. Okay, so this inspired somebody here in this picture. You look at this picture. This is Russell Porter. Okay, Russell Porter, Einstein had visited the Mount Palomar telescope observatory. At that time, it was the largest telescope. Now we have Hubble and other things. But at that time, 200-inch telescope was the greatest telescope in the world. And on the Mount Palomar, it was called as the Mount Palomar 200-inch telescope. And Einstein once visited this Mount Palomar observatory. And this Russell Porter was the chief scientist there. And he took Einstein around and showed the whole achievements of the Mount Palomar Observatory. And he showed these achievements, and he told at the end of the visit, he told Einstein, Russell Porter told Einstein, Professor Einstein, I've been watching stars for the last 30 years. I've been watching one star after the other, discovering new star and new star in our observatory. We found so many stars in the last. And then I realized one thing, that there is this huge universe. Inside this, there is a tiny Milky Way. Inside that Milky Way, there is a tiny solar system. Inside that tiny solar system, there is a tiny Earth. Inside the tiny Earth, there is a tiny country called India. Inside the tiny country called India, there is a small, tiny place called Belgaum. And inside, okay, let me say Dharwad. Okay, inside that tiny place called Dharwad, there is a tiny place called Higher Education Academy. Inside that tiny place called Higher Education Academy, there is one stupid fellow, Shivprasad, sitting and talking, right? So how insignificant we are to this universe, right? Does it matter whether we are alive or not? Does it matter we do any science or not? Does it matter to this universe that we do something or not? Is the question Russell Porter asked Einstein. A very humbling question, right? Somebody, a scientist who was a very accomplished scientist at 30 years, at the end of 30 years, started feeling, my God, I wasted my whole life. Does it matter? Now we walk, we trample on an ant and the ant dies. Okay, who cares? The world goes on, right? How many bacteria, viruses are being killed every day, right? We are also struggling now to kill that virus every day. Does it matter? Okay, so if I live, if Shivprasad is alive or not, does it matter? This is the question Russell Porter asked Einstein. And what is the answer? What Einstein gave is something I want to share with you. Einstein gave a very beautiful answer, and that is how he is great, not only because of his science, but the way he looks at life. And very important for a scientist is to weigh how you look at life. So Einstein said, I agree with you, Russell, that we are so small, but isn't it wonderful to know that we are so small? Probably any other creature in this world doesn't know that there is a universe, there is a solar system, there is a Milky Way, there is that, nobody knows. Probably only human beings know this. And that is the opportunity of being alive. Then he says, Porter, we also know, we know about electrons, atoms, protons. We know compared to the electrons, protons, we are so big, right? We are not small. So the beauty of life is to know that we are both so small and so big. And he says that is the purpose of our existence, to know that we are both so small and so large. We are not so large that we can become egoistic. So ego should not enter into us. And we are not so small that we think we become inferior, we get the inferiority complex. We are so large. So we are both large and small. So it's very important that we should not have ego and we should not have inferiority complex. So this is what the message Einstein gave, and that is very important. And what is the best way to know this, that we are so small and so large? Earlier people used to think poets, literary people, they painted a picture of this beautiful world, or painters, okay, amazing, they did some beautiful pictures. But in my view, they all fall short from the beauty science can see. The beauty which science can see is much larger than the beauty an artist can see, a poet can see, or a writer can see. right? Of course, they are also beautiful. They know how to describe it so beautifully. But the realism of the beauty comes from science. And that, I think, is an inspiring point of why we want to do science, why we want to become students of science, right? So now you see here, there is these are again some wonderful people who are there. C.V. Raman, of course, all C.V. Raman said, ask the right questions and nature will open the doors to her secrets. The whole universe, the nature is a secret, right? It is so we don't know. We are trying to reveal one after the other, one after the other. And the only way to unreveal this is to ask the right questions. So please understand, friends, asking the right questions was done by C.V. Raman, J.C. Bose, Satyendranath Bose, Meghnad Saha, Sihana Rao, and so many other people are able to ask these right questions. And they've been knocking on the doors of nature and tell, I'm knocking on the door with my right question, open CSAM. And CSAM opens and gives her answers and say, this is how I work. Right? So it's so beautiful, right? That I think is a very important thing for all of us. Now look at this. Okay, let's come to some mundane things now from philosophy. Let's get down to the earth. Look at this. There are two kinds of people walking on ice. One is my fat friend penguin, and the other is my ex-girlfriend. I don't know. I don't want to call that, but some beautiful girl who is doing the ice skating. Look at the control. My fat friend here can't walk. He slips on the oops. He falls down. And here, look at this amazing girl. What is she doing? How is she playing on? Shweta, can you think of doing something like this? Okay, it's not possible, right? But it is possible. Shweta, if you practice tomorrow, next year you will be doing this, right? So why? How does this happen? Right? Is something we need to understand. So let's see. Oops. Okay. Now see here. So what is important is the kind of shoe she is wearing. The shoe is this kind of which has got a very sharp edge, and that pressurizes and does something that you can skate, right? To understand that, we need to come here. We need to understand, why does ice float in water? Ice is a solid, right? Why is it less dense than water? So why is it floats than water? This is the question a school child will ask. School child will ask, why does it float in water? And why does it float in whiskey? Right? Very important. On the rocks, right? How does it float on water? This question a child asks, because we keep telling, when it becomes solid, gas to liquid, liquid to solid, it becomes denser and denser, and so it has to sink. But you look at here, there is a solid phase which is floating. A simple question, a school student. With this curiosity, he goes ahead in the college and tries to understand the phase diagram of water. Only if you understand the phase diagram of water, you will be able to tell why, when she uses that sharp edge, the pressure increases, and when the pressure increases, okay, my water melts. So that can be understood only with the phase diagram. And that is what you do in a college. The same question. The question is, why does my fat friend fall, and why my talented girl skates? Is possible to understand only with the phase diagram. That girl who is skating doesn't know this. Doesn't know the phase diagram. But the basis of that is this one. Now the college, he becomes more curious and goes to the university and starts thinking. Then he wants to understand what is the structure of water. Then he understands what is water. Then he finds out it's called as H2O, and there are two bonds, 100 so many degrees, tetrahedral bonding. That this he tries to understand. And then he finds out how water bonds with each other. What is a hydrogen bond? How water? Then only I can explain the phase diagram. Then I can explain why the ice floats in water. Then I can explain why the skating is happening. So beautiful, right? It is not possible. Then you go one step ahead, start doing your PhD, become a researcher. Then you start understanding this fine structure of atoms. Start understanding what is this hydrogen bond, tetrahedral, etc. Why does it bend? Why is water so unique? You know that there are millions of questions still not understood about water. The simplest water, okay, is not understood. I find it very amusing. Some people say, chemical chemical. What is not a chemical? Everything is a chemical, right? What is dihydrogen monoxide? Is it not a chemical? It is nothing but H2O. It is water. So water is also a chemical, my friends. So this is a common man calls a chemical, a chemical. Friends, it is about toxic chemical and not toxic chemical. It is not about chemical and no chemical. So we have to educate being science students of science that everything in this world is a chemical only. You tell them, hey, don't drink dihydrogen monoxide. Right? So, he'll panic. But you tell him it is only simple water. Right? So please understand that is the beauty what science gives us, that insight into things which happen in this universe. Right? So you go from a normal observation, okay, go step by step and start going into the atomic and molecular picture. Right? So that is being a scientist. Scientist is looking at a normal observation, trying to understand it, and by the time he understands it, he will be ending up with atoms and molecules. Otherwise, it is impossible to understand this science. And that is the beauty of science. And that is how we are lucky to be students of science. Now, let's look at this. Look at these people, amazing people, right? These are all outstanding people. Our pride of India, Aryabhatta. Look at the amazing observations he made in those days when there was no telescope available, nothing was available. He was able to make these amazing observations. Then you know Galilei, he had made some preliminary observations, but it was taken so much forward by Galileo, and Galileo's time is considered as the time real science started. Everybody had thought about it. The Chinese had thought about it. The Mesopotamians had thought about it, studied about it. Mexicans have started. Indians had done about it. Everybody had done the revolution, but ultimately it had to be converted into a science which is reproducible and doable. And that started from the time of Galileo Galilei. Okay, this is, if you're not ready, please, I suggest that you read this book. Okay, read this book. Somebody please mute it. I mean, we are getting some disturbance from somebody. So please mute it. Please. Okay, I'm sure they're already trying to look at water, breaking up water and finding out molecules. So that's why the noise is coming. But it's okay. So look at this book. If you have not read this book, please read this book, Carl Sagan. It's a very old book, early 1980s, which inspired me as a student. So I'm sure it will also inspire you. It's so beautifully written. Carl Sagan was one of the greatest storytellers of science. He was also a great scientist. Okay, the book is called as Cosmos. It was also a video series. I don't know if it is available on YouTube. Maybe it is available on YouTube. Look for it. Okay, amazing. I read a book, but I'm sure it should be available on it was also a TV serial in earlier, but now it must be available in YouTube. Please look at it. And it gives you a beautiful voyage of this whole world and the possibility of other lives, and amazing. Carl Sagan is an amazing person. So I think you'll start liking him. Okay, now let's go ahead. After this science started from Galilei, then came Isaac Newton. When his grandfather was also there, apples were falling down. When his father was also there, apples were falling down. Okay, everywhere it was falling down. But Einstein asked this question, why is the apple falling down? Right? You know, because, see, my grandfather also saw, I also saw, but until I read about Newton, I did not know that they're falling down. Right? We took everything for granted. Only when we went to school and told Einstein, and then we heard Newton saw that the apple was falling down. Then he thought about gravity. Then I also, we also never thought about it. Okay, and that is what it is. Why Newton could see that is not because nobody saw it, but he was a prepared mind. Newton was not an ordinary person. He was a professor of physics in Cambridge. Sitting, imagining, being curious, and everything. When you are curious and you was trying to understand the Galileo's theory of how planets move, and he was trying to understand why do they go in circles around each other. Then he said there should be some force which is pulling each other. Then he was thinking about it. Then he realized, oh, everything falls down because something like gravity, right? So the gravity, the concept of apple fell down or not, in reality, we don't know. But I mean, that may not be a real story also. But the idea came to him why things fall down. Okay, so very important for us to understand. Then to understand this concept, just that gravity, he went on and on and on for 20, 25 years. And he found out the laws of motion. Okay, he found out what is gravitation. Then he found out even optics. He also invented calculus, right? He did everything because he wanted to understand all this. Then, he didn't even know where this will be applied. Now we know his laws of motion, his gravitation are used either for space shuttle or for a satellite or for cars moving, or just when we throw a stone at somebody, everything follows by these laws, which so beautifully defined by these people, right? By these wonderful people. I mean, person called Newton, and that's how things changed. This was about in the 1600s, right? About 600 years ago, right? So, and then our Kanada Rishi, right? The Rishi Kanada, long ago, 600 before Christ, 600 years before Christ, thought everything when you break and break and break, you come to a small thing. It should come to something small and which should become unbreakable, right? Something very small on which everything is built. He imagined this. His curiosity. When I break this pen, tear this paper, what will happen? Where it will become very small. He started thinking, and ultimately he said there should be something called as kana, right? And what we now call as an atom. He predicted this. But then about 200 years later, okay, 200 years later, approximately 150 years later, Democritus in Greece, okay, defined what is an atom much more clearly. Kanada just imagined something should be there. But Democritus started telling this will be indivisible. He started finding out something is indivisible. And that is how, I mean, he talked about it. Then came Dalton long ago in 1800. See, about 1800 years, it took more than 1800 years. It took, 1900 years it took for Dalton to start thinking about Dalton's atomic model. Then plum pudding model, all sorts of things which we study in school. Then J.J. Thomson came and said, oh, it is a mixture. Then he found out there is a nucleus. Then Rutherford said there is a nucleus. Okay, he did some experiments to find out. Then see how many years it is taking in between 1800 to 18. See, about 90 years from Dalton to Thomson, right? From there, it is only about 20 years for Rutherford to find out the nucleus. Then, okay, immediately after that, Niels Bohr find out the Bohr's atomic model. He bored us in our college with his Bohr's model, right? And after that, then the modern concept of atom came. Einstein contributed with his photoelectric effect, right? Many people, Schrodinger, Feynman, all sorts of people. The modern atom was discovered in about 1930s, and Louis de Broglie. Okay, Louis de Broglie was the one who found out something very interesting from this beautiful experiment, one of the greatest experiments ever in the history of physics, which is called as the double slit experiment. This is something which inspired Raman also in his life. A single slit experiment started. So this wave nature. Then we realized that atoms, electrons are not just particles, they are also waves. They also told that we are also waves, but with very, very tiny wavelength. We are also showed that there is something very important. So this is important. It's one of the greatest experiments ever done, which is the double slit experiment, which gave us this concept of wave, which ultimately led to so many things, what is called as quantum mechanics, or it's also called as the wave mechanics. The classical theory of Newton explained when things were treated as particles, as a mass of particle, no wave. But ultimately, if you want to understand many other phenomena, which Newton's law could not help, okay, then we understood we need something like quantum mechanics, for which the birth was given by Louis de Broglie. Okay, the wave nature. Then we know with the wave function, then the concept of wave with the Schrodinger's equation, the concept of wave functions. Then look for the hydrogen atom. When we saw, then we see different kinds of electrons travel in different paths. Very beautiful. This concept, I did not appreciate when I was a student. Now I understand when I'm an old man, I understand. So beautiful. The s electrons have a spherical. Okay, d electrons have this shape. P electrons have this shape. Such beautiful things. And this shape of these electrons, how they move, why they move is also very important, right? There is one concept in physics, which is minimizing energy. If you know how to minimize everything in nature works on minimal energy. So the whole concept of physics or chemistry or any science is how do we minimize energy? And when you minimize energy by using the Schrodinger's equation, we can actually find out the different electrons minimize their energy by traveling in different shapes because of the presence of other electrons, because of their character, because of so many things in that. And then we lead to what are called as quantum numbers. Right, the 4 different quantum numbers. Suppose I want to characterize Nagara Hegde sir. I'll tell him he's a very smart guy, beautiful mustache, okay, very nice, smile. I can define him by 4 characters, right? So at least 4 characters. He has many more good characters, but I'll define by 4 characters. An electron, which all looks the same. In the canonical ensemble, every electron looks the same. But if I want to define a particular electron, it depends on where he is, which orbit he is, what he is doing, what the electron is, he or she is. I don't know, electron is negative, so we'll call it as a she. Okay, a she, what is the electron, what is she doing? Okay, is she in its orbit? How can I characterize her? Then I need these 4 characteristics which are called as quantum numbers. So beautiful, right? Every electron is same, every human being is same, but depends on what you do, where you are defined. And that is something you see in these electrons also, in all the nuclear particles, you start understanding. And there are some very interesting concepts. I can go on and on, but which you all know. It's so, I mean, it's so inspiring, right, to see how we went from one knowledge to the other, one understanding to other, how we get into the nucleus and start seeing what happens in the nucleus. Now there is something very amazing called a string theory. Please look at all these words which I'm telling in the YouTube. I have become mad in the last 2-3 years. I've become a YouTube fan. Every day, earlier I used to get up at 5 o'clock. Now I get up at 3:30, and 3:30 to 5, I watch YouTubes related to physics and mathematics. And it is so beautiful, things are there. Okay, you can see amazing things which are there. You will see all these pictures. So please watch your YouTubes. Find about 1 hour every day to watch your YouTubes on physics and mathematics. And they are very pretty, which is also biology probably. I mean, every subject is beautiful. But of course, the most fundamental science is physics. And the most fundamental language is mathematics. Mathematics is the language of nature. So we need to understand both of them together. This is what scientists have done. Now let's look at this person. What did this fellow do? The famous Einstein. What did he do? He asked one question. Newton asked this one question. Why does the apple fall down? Now Einstein asked this beautiful question. He asked this question. How will the world look when I sit on a ray of light? Einstein came to know that the light travels at a velocity of 3 lakhs kilometers per second. Right? We all know that. Then he started sitting and imagining, if I sit on that ray of light, adar ಮ್ಯಾಲ್ ನಾನು ಕುಂತ್ರೆ ಜಗತ್ ಹೆಂಗ್ ಕಾಣ್ತಿತ್ತು ನನಗೆ? If I go in a train, how does the world look to me? If I go in a plane, how does the world look to me? Okay, in different speeds, if I walk, how does the world look to me? But what happens if I sit on the ray of light and travel at 3 lakhs kilometers per second? This is the question Einstein asked. And he spent so many years trying to understand this question. Ultimately, when he understood this question, came the theory of relativity. Right? We know that there's a general theory of relativity, a special theory of relativity, all those beautiful things. Then he came out with this concept of the constancy of the velocity of light as the only constant thing in this whole universe. Everything else is relative. Now, time hogid sigangilla anteli, but Einstein showed that you can also change the time. Right? When you go close to the velocity of light. So nothing else in this world is constant except the velocity of light. This gives you an opportunity, my friends. If you can come out with a theory which shows that light is also not constant, or you can find a particle which travels faster than the velocity of light, a Nobel Prize is guaranteed for you. Okay, please understand, there's a beautiful opportunity for you in your lives. That to show that there is a particle which can travel faster than light. There's one Dr. ECG George Sudarshan, who was an Indian who was working in the University of Texas, went on to show something called as tachyons. And he said that there are tachyons which can travel faster than light. But ultimately there was some problem, but amazing discovery he also did, but ultimately it was shown that Einstein was correct. Even the recent experiment of the LIGO experiment, you know, that the gravity waves experiment, which was done just only a few years ago, proved again that Einstein has been correct up to this point. So now we know Newton was not correct. See, that is the beauty of science. We respect Newton, but we can tell him that you are wrong. You can't do this in any other field. I can respect your principal Hegde sir, but I can not tell him that you are wrong. Then he'll get angry with me. But in science, it's not like that. You tell anything in reality, you tell anything, we accept it because it is scientific. Right? So science is the only field where you can say that somebody was wrong. Einstein showed that Newton was wrong. Newton showed Galileo was wrong. Everybody went on showing that they were wrong, and they found a new way of explaining things, right? So beautiful. So there is no end to science. I'll again show you at the end of my talk that there is an end to my talk, but there's no end for science. Okay, very important. So this is what E is equal to mc square came. So many, you know, the three amazing papers in 1805, I mean 1905, which Einstein came, and that's why we celebrated 2000 year as the year of physics, because three amazing papers were published by Einstein when he was a very young clerk he was a clerk. He was not a scientist at that time, but he found out three papers. So to become scientist, you don't need a PhD, you don't need a research paper. What you need is a brain which can be utilized. We all have a brain, but it has to be utilized. That's all. It has to be utilized properly. The right questions have to be asked, and you have to be curious, imagine things. So that's what it is. So this is what Einstein did. Now let's look at this fellow, Lord Rayleigh. He was very curious. So when his grandfather was also there, the sky was blue. When his father was also, the sky was blue. Every time my grandfather also time, it was sky was blue. And I was also seen that the sky is blue. So many poems have been Neele Gagan Ka Akash, you know, we have sung songs, so many songs. We have done so many things thinking about, but Lord Rayleigh asked this question, why is the sky blue? So he asked, why is the sky blue? And tried to answer this question, Lord Rayleigh. Okay, you know that he tried, and then he found out this is about scattering of light. The blue happens not in the sky, it happens in the atmosphere. He showed that blue is in the atmosphere. The sky is not blue, the atmosphere is blue. That's what he shows. The sky is black. If you go beyond the atmosphere, you go and see the whole sky is black. It is not blue, my friends. It happens to be blue only inside the atmosphere. And that's what he showed. And then he showed, why is it blue? He showed with this beautiful expression, what is called as Rayleigh scattering. He said that, look, you look at blue light, it has a smaller wavelength. So it scatters more when it hits a dust particle or a water molecule or something inside the space, because it is of approximately the same order of magnitude. The wavelength of that is of the order of this. And that's why it scatters. When it scatters, it goes sideways and hits other molecules. And that's why we see the blue color. So why does red not scatter? He shows because the wavelength is longer, it will miss the scattering, or the scattering probability becomes less. And that is why red light and other light, green light, everything come to our eyes. And so we see only the sky as blue and we don't see them as red. But very interesting, there's a homework for all of you. If this is true, if Rayleigh is correct, why is in the evenings, why is the sky orange or red? Okay, and not only that, you have seen this. In the afternoon, the sun is very small. But when it is going down, right, when it's about to set, the sun becomes very large. It becomes red and large. We all go and stand and see this. Okay, we all see this. Oh, beautiful. We take out our mobile phones, click, click, click. Okay, pose kottu, we take a lot of pictures. But we don't ask this question, why it happens. Now that you are students of science, you go and see that the beauty is not seeing that beautiful sun which is red, but beauty is to understand why it is red. So I request all of you, I'll give my email. Please find out the answer for these questions and please answer. This is again a small homework for you. Okay, now this did not end here. This did not end here because now we had our own friend from India. He says, who is C.V. Raman. He asked this question, if the sky is blue because of scattering, then why is the sea blue? Can I request Samata and Prajakta to please switch on your videos? Okay, please switch on your videos. I'll happy to see your faces. Yeah, okay, because I can see only few faces and you are, you are unlucky to have your names there. So please switch on your videos. Prajakta Ghasari and Samata Hiregowda. Okay, please switch on your videos. This is my request. Okay, right, because I can't see any other faces. That's the problem. I'm only seeing Nagaraj sir's face, but okay, now I can see Sweta's. Okay, I've shifted down. Prasad sir is there. So Prasad sir, you have beautiful design in the back. There is some very nice mathematics for that design. Okay, of your curtain which is there. Do you know what is that mathematics called? Okay, you please find out. It's very, very, very nice. Okay, Prasad Kode sir, I'm sure you know about it, but look at these kind of patterns have very beautiful mathematics. Okay, we'll come back to that a little bit later. But now see, this is what happens. Okay, then C.V. Raman asked this question. If the sky is blue because of Rayleigh scattering, why is the sea blue? Okay, he wrote a letter to Rayleigh asking him, why is the screw? Oh, thank you, Samata. Okay, see, I wanted to see your beautiful smile. Thank you for switching on your video. Okay, so Raman asked this question: if the sky is blue, why is the sea blue? Then he wrote a letter to Raleigh to ask, why do you think the sea is blue? Because I don't see that scattering happening. Raleigh said, even I don't know. I think probably it is the reflection of the sky in the water. Then Raman said, no, 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 no. What is this? You think you call yourself to be a great scientist and you just don't know this. Then Raman started working on that. He did a long experiment, many experiment, and he discovered what is called as the Raman effect. You know what is Raman effect is very simple, as you all know. It is not at all a complex thing, Samata. Okay, Raman effect is a Nobel laureate of India. We should know what is Raman effect, right? So what Raman said is, we know that all molecules are not quiet. They are moving. There are different kinds of vibrations in them, right? So when light hits that vibration, what happens? Let us say, a molecule is here and light comes and hits here. If the molecule is very small and this is very heavy, it will just come and scatter like this. And nothing happens to this molecule, but the light only gets scattered, right? This was Rayleigh scattering. So the energy of the light which comes remains the same even after scattering. So it is called as elastic scattering. Right? Means there is no change in the energy. Like an elastic, it has a certain size, you pull it and leave it, it comes back to its own size. So same thing happens to the light. It comes here, hits it, and goes back to the same energy. That's why we call it as elastic scattering. Okay, now Raman said, but if the molecule is vibrating, what happens to the energy of the light? So he said, it is vibrating, a photon with a certain energy comes, hits it. If it is moving in this direction, this photon will lose energy. If it is moving in this direction, it gains energy, right? So there is an inelastic scattering. Then inelastic Rayleigh scattering is nothing but Raman scattering, right? He just found out that because molecules are vibrating, they sometimes gain energy and sometimes they lose energy. Is it right, Prajakta? Okay, so is it clear? Okay, he found out that. He says if they are vibrating, it should be there. He just didn't imagine and keep quiet, right? He started doing this experiment to find out. You know that Raman was not even a scientist. He was like an IAS officer. He was in the accountant general's office. Okay, he was an accountant. Okay, but he had curiosity in science. So later he left that accountant's job and became a full-time scientist. Okay, then he became the great scientist because he said he was earning when he was doing the job, he was earning a very high salary. At that time, he was earning something like 180 rupees salary, which was supposed to be like maybe something like 10 crores, 10 lakhs. His salary was getting. But he left the job and came for a very small salary in the Indian Association for the Cultivation of Science, which was about 1/10 of what he was getting. He was getting only about 18 rupees salary. But he left it because he was curious. Think, Prajakta, that is more important. It is not the salary. It is not the Gadi Bangla, suit, which will make you a fantastic person. The first fantastic, ellaru car tagonತಾರೆ, ellaru money kattisತಾರೆ, ellaru ಮದುವೆ ಆಗ್ತಾರೆ, ತಗೊಂಡು ಏನು ಮಾಡೋದು, right? Everybody, very important is to do something very beautiful, which we love to do, which we are curious to do. And that is what Raman did. And ultimately he found out with this simple experiment with using a 160 rupees equipment. Okay, 160 rupees equipment. He was able to find out what is called as Raman effect, which is called as the Stokes and anti-Stokes. The one which gains energy and the one which loses energy gives you this energy change because atoms and molecules are vibrating. This is all Raman found out, and that has become a great field now. Raman effect. And it became much, I mean, if today Raman was alive, he would have been happier because once we found out, we invented lasers and started using them, we could also now, when he did it, it was possible only to study on liquids. But now we can do on solids, we can do on different kind of materials. And that's why Raman, now in the 1970s or early 80s, a new concept came, which is called as a surface enhanced Raman spectroscopy. By using nanoparticles, using plasmonics, coupling the plasmonics with the Raman emission, we could enhance the signal further, and it's called. And now it has become an extremely powerful technique to study anything, especially to detect early diseases. Now, even to find out COVID infection, people are using Raman spectroscopy. Okay, so surface enhanced Raman spectroscopy. Even to find out AIDS, people are using. All sorts of things are being used by this kind of a spectroscopy because of Raman. Just because he was so curious to find out why the sea was blue. Right? One question which really led him to the answer to what we found out as a Nobel. And you know that Raman was such a proud man. He was so proud that the day actually he was not there when the experiment was done. His student Krishnan was doing the experiment. He saw this effect. Krishnan, and then he called professor and he said, sir, what you were telling, we saw it today. We saw it today. After a long time, we saw that small peak, that Stokes and anti-Stokes peak. We saw that small peak. Then Raman said, before he saw that experiment only, he called the travel agent and said, book my price to Norway because I'm going to get the Nobel Prize. He was so confident that he can do that. That self-confidence was there in Raman. But of course, after some time in 1930, he got the Nobel Prize. And you know what is another beautiful thing, Prajakta, is he doesn't celebrate his birthday. We don't celebrate C.V. Raman's birthday. We celebrate the day when he found out the Raman effect, which is called as the Science Day, February 28th. You know that? Okay. So very important for all of us to, we are all born. So celebrating birthdays is not so important. But ultimately how we have lived and what we have done. And that day is more important for us. And that is the day we want to celebrate. We want the world to celebrate. Now only Prajakta's friends and family are celebrating her birthday. But after some time, okay, the whole world will be celebrating Prajakta's discovery, right? Her invention. And that is what we need to do, right? We need to look at that time when what we do becomes important rather than what we are. What we are is not so important. Okay, what we do becomes terribly important. So that's what it makes again a scientist. Now let's go to the next slide. So now this person, okay, Bernoulli, he started thinking, oh, how does big birds fly? What is in the wings that it makes it fly? What happens at the wings? When the bird flaps its wings, what happens? Right? You start thinking, then he started thinking, what happens? Then he realized there is a pressure difference which is created. Right? And based on that, now we know we have made aeroplane wings. Look at this aeroplane wing. What you do by just the shape of the wing, you make sure that there are less molecules above and more molecules below, just by changing the shape. And once we change the shape, we know that we can lift a whole aeroplane, the Airbus with about 400 people on board, 600 people on board. The plane can be lifted by just creating the pressure difference between the wings of on the up and bottom of a wing. Amazing, right? Right, Prajakta? So simple concept of Bernoulli is able to make huge objects fly in the sky. Right? So very important how Bernoulli. Then we had this person, our friend called Archimedes. We all look like him once in a day, every day, right? We look like him, but we don't come out so happy after the bath, right? Because when he went into the bathtub, he found out something very interesting. When he went into the tub, the water came out. Now he started worrying, how much water did it come out? When I go into the tub, how much water will come? When Archimedes go into the tub, how much water will come out? When Sweta Dalvi madam goes into the tub, how much water will be displaced? When Prajakta goes into the tub, how much water will be displaced? These questions he went on asking. And then he found out what is called as the Archimedes principle, from which he could detect the density of materials very accurately. In those days, he could find out a way of measuring it. He could actually distinguish between gold and copper. Okay, it was a challenge given by the king to him to tell him, find out how my goldsmith mixes copper into that. Here he makes an impure gold. How when you mix that, how to find it out? And that was a challenge given by the king, which Archimedes took and said, how do then we found out he came out with the concept of buoyancy. Right? Buoyancy. You know, I am 100 kilos. I'm always worried about losing my weight. I struggle very hard, but still, mirchi, girmit, pav bhaji, I can't resist. So I eat them and so my weight doesn't go down. But I feel very happy when I get into a swimming pool because, I feel so light and happy and I feel I'm as thin as Prajakta or something like that. So I feel so happy that I've lost my weight. Okay, you understand? Or Samata is even thinner. So she is so happy being thin. Okay, I'm trying to lose weight like her. Okay, so that's what he tried. Then we know concept of buoyancy. And once we know the concept of buoyancy, then we could design big ships, huge ships. Look at this huge ship. It can carry a city. Now planes come and land on ships, but they don't sink. But you try to put a small pin, it sinks in water. Okay, because this concept of what Archimedes said was the concept of buoyancy. right? If we can understand what this is, we can also think of new ways of utilizing this. Maybe Archimedes has not understood everything about materials. Maybe our Samatha will soon find out something more about this. So that's what it is about how objects fly. He started asking. Now, this question was there. He's Charles Darwin. Charles Darwin asked this question, why am I better than my father and my mother? I told this to my father that I'm better than you. He said, no, no, no. What is this? You cannot be better than me. I'm better than you. Always, all parents say, ನಾವೆಷ್ಟು ಚಲೋ ಇದ್ವಿ ನೀವು ಹೆಂಗಾಗಿರಿ ಓಡಾಡ್ರಾಗಿರಿ ಹಾಳಾಗಿರಿ ನೀವೇ parents say this. But I told my father, no, no, I have proof. Charles Darwin has proved that I am better than you because you are more closely related to the monkey than I am. Right? He is more closely related to the monkey. So my father is more a monkey than I am. So I told this to my father. It all went very well. Of course, my father is not alive now. But my problem came when now my daughter tells me the same thing. He says, I am better than you because you are more closely related to the monkey. So this Charles theory of trying to understand why things are becoming better and better, okay, gave the concept of the origin of species or the theory of evolution. It was an amazing contributor to science. Okay, why things are different, why a plant is like this, why a monkey is like that, why a tree is like that. Everything is evolution. This concept of evolution revolutionized the way we look at things. There were many people, even now in the Western world, we don't want to believe in Charles Darwin's theory of evolution. They say, no, 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 God made everything. Okay, everything. God decided to make man, monkey, etc., etc. But I'll tell you, Darwin has very clearly shown how mutations take place. Now we know with the virus, we know about mutations much before than what we knew earlier. So every species mutates. And the one which survives, it doesn't mutate into a better species. It just mutates by mistake into different errors, by mutational errors, right? By genetic errors. They mutate into different things. Out of that, only those which can adapt to the circumstance survive. And that is what the theory of survival of the fittest came, right? The Charles Darwin's theory of origin of the species, the beautiful book called as Origin of Species, which gave us a lot of insight to how plants and animals have evolved over the species. Amazing world. Now we know about migrations, everything about this. Then we have another person, another question, another fellow asked this question, why do we look like our parents? If we don't look like our parents, there is a serious problem. Especially if you look like your neighbor's father, then you are in a much more serious problem, right? So we all look like our parents. So this question was asked by Gregor Mendel. What is genetics? How are features carried from parents to the children? Right? He asked this beautiful question. He studied on pea pods. He didn't know there is something called as the DNA and genes and everything. He didn't know that word at that time, right? But he just wanted to see how properties change from parents to children. How do you study this? It becomes very difficult. So he started studying pea pods, watani gida, because they had a very short life of about less than 2 to 3 months. So he could study thousands and thousands of them, breed them, do that, and find out how the features change. See, you can do this experiment in your house also. You can take some pea pods, start measuring the properties, physical properties, okay, and list them, and go on changing. Find out two plants, okay. Take the when the flower comes, take the pollen from one plant, put to the other, form another thing. See, this is what is happening, right? It is the pollen, and in father and mother also there is something which is exchanged. So this is what it is, the pollen grains on the stigma. You do that experiment and see what are the properties of the peas which grow in that new plant. Okay, and the seed which comes and they grow the new plant. So like this, Gregor Mendel did for about nearly 13 lakhs pea plants. Not 1, 2, etc. His observation, he did it for about nearly 13 lakhs. He not only did it in England, he traveled all over the world studying pea plants and the properties. He took a ship, and even on the ship he was growing pea plants. Watani was his life. Madi, he understood what are the Mendel's principle of heredity, right? He came out with that. Now we understand that is because of the DNA, there's because of genes. So many beautiful things we understand now, how this all happens. And that genes, now we know from that how migration of people took place. Combining Mendel's principles with the Darwin's theory of evolution, you could actually find out how we migrated, where life started, why it started there, how we have moved, how the generations have taken place, who are the people in Australia, who are in India. These all things can be done by looking at genes in the genetic code, right? Such a beautiful thing which has come because of these wonderful people who asked this question. Darwin asked the question, why am I better than my father or mother? And Mendel asked this question, why do we look like our parents? And why do we don't look like our parents? Some things we look like our parents and some we don't. So what happens is something the hereditary law says, right? So next, of course, now I think I should jump now. Okay, there are like this many questions are there. I don't want to go here. We know Mendeleev, who looked at properties of elements. There were only 30 elements at that time. You see, this is the picture. This is a famous picture which was recently found out when somebody was cleaning his desk in France. He was cleaning his office, and he found out this picture which you see here in the bottom, and that was the original handwriting of Mendeleev. See, and he had found out the known elements at that time. He put them together and found out which properties were similar or not, and put them in a column. And of course, he based it on atomic weight. But ultimately, we know by adjusting through atomic number, we have found this wonderful table, better than the wooden table, better than the steel table, better than the golden table, the periodic table. Periodic table is the best table in the whole world, and very expensive, much more expensive than any other table. You know why? Because it has gold, platinum, silver, everything inside that. So it is one of the most beautiful tables which actually gave rise to the history of chemistry. Chemistry became so beautiful because the periodic table was understood. The properties of elements and how they behave. At that time, they didn't know there were electrons, protons, right? At that time, they didn't know, but they just found out by observation. That's what I keep telling. Observation is a terribly important thing. They were able to put things together in a periodic table, and now we know every material is made out of this. And this question, why are properties of different elements similar? He just classified them. A classification helped him come out with this beautiful table, which is still not fully understood. Okay, you must have read a book by Levy, the book called The Periodic Table, very interesting. Okay, still not understood. So many unknown things are there with the periodic table, and that is what it is. And we have all studied periodic table. I used to, when I was a student, it used to be a headache. Who has to remember all this? First group, second group, then third. Now I realize how beautiful it is. I wished I had known that it is a beautiful table when I was a student of your age, Samatha. Okay, I did not understand at that stage. I thought yado one cat boring master enu torsakatare, chemistry master telila. Okay, he's showing this terribly boring thing and tele. Avaru ashtu yakandre ashtu boring age helidru avaru. That is why I never enjoyed that. But now the question is, now I realize when I understand on my own, okay, ಏನು ಅದ್ಭುತ table idu. You can actually discover many more things even today, Samatha. Very periodic table in the you can become a scientist just understanding the periodic table. Understand all the properties of periodic table on the elements, the distribution, how they are. See how periodic elements in fact were detected like that. Illa element nadu one gap itti illi irabekku one element, and people started looking for it. That is how the periodic table was filled up. So like that you have an opportunity. And one beautiful thing about the periodic table is Samta, that when you identify a new element, you can call it Samata element. Okay, Samata andre SM annak barangi because already samarium is there, but we'll find out something. ST is not there, so we'll call it as ST element. Then ultimately one day when Samata will discover a new element in life, we'll call it as a ST element. Agreed, sir? Nagaraj, sir? We'll all call it as a Samata element. So this is possible. You look at that, there is a Einsteinium, there is a fermium, there is people, it has been named on people who have discovered so many things, or people we wanted to respect for some of the discoveries. Okay, this is something you can still do. Understanding a periodic table, it's very deep. Just not understanding, never try to remember anything in this periodic table. Understand it. I think you will do it, because remembering why, you can always see it in your mobile phone. Why you want to remember all that? Unfortunately, our examination wants us to remember so many things. It is not necessary. Information is there. Now you have to take that information and think about it and come out with new ideas. And that I think is very important. Okay, this is the periodic table. Now you see, after the elements were found, then we had somebody called as Linus Pauling. Amazing. He started understanding all elements are there, but ultimately how do they bond together to form different materials? What is the bonding? What are the different bonds we know? We know the ionic bond. So many bonds we know. Ionic bond, the covalent bond, the hydrogen bond, the metallic bond, the James bond, the Brooke bond, the Anna bond. So many bonds are there. So we need to understand all these bonds, and that is what Linus Pauling is found out what is called as the chemical bond. He wrote a beautiful book called as The Nature of the Chemical Bond. It's an extremely amazing book which tells you about how the bonding takes place. So the real James Bond is Linus Pauling. The real 007 is Linus Pauling, the real who found out about the different kinds of bonds. Okay, so now let us see. Then from this bonding, then we started understanding biology. We started understanding large proteins. Okay, how do proteins form? Then we know everything we are made of is out of proteins. Right? Most of the things are proteins. We understood large molecules. Then the structure. One of the greatest protein we have ever seen is the DNA. And this was discovered by Francis Crick Watson, Rosalind Franklin. She was the one who was actually doing microscopy to find out this. Can I request somebody to mute your
Soumya, please mute
Soumya, please,
yourself.
please mute yourself. Yeah. Okay. Fine. Okay. So now you see. So now Soumya is very excited. She wants to do some science. So she's throwing trying to find out a DNA in her house. Okay. Very nice. Very nice, Soumya. So now you see, this is the DNA which was found out world. So Rosalind Franklin and Wilkins were the people who actually did the experiments. Who were doing microscopy to see this. But the concept and the idea was given by Crick and Watson. So you know that it's called as the double helix model, or the Watson and Crick model of the DNA. And let me tell you, friends, it is not only with biology. Now DNA is studied maximum in physics. Chemistry we're already studying, but now for physics, it's a great material in physics. In microelectron, then now DNA integrated circuits are being formed. Inside a DNA, Samata, you can find an insulator, a semiconductor, and and a conductor inside a DNA. It is such a beautiful electronic material now. So people now want to make integrated circuits by using this structure to make transistors and diode in these materials. So the future of electronics is DNA electronics. It's something very beautiful. So it is no longer biology, it is physics. See, you understand? We think, hey, the biology, now physics, but it is something very beautiful, and they are linked to each other. Because after all, they are materials. After all, they are elements. After all, there are electrons. After all, there are protons, nothing else. Right? So, namanga, kannu, and the moogu, and the bai, and kiwi, same, we are all same. Now the question is how it is utilized, how it is bonded with others, which makes all the difference. So then we had G. N. Ramchandran in the Indians of Science, Bangalore. There is a great scientist. We all expected that he would get a Nobel Prize. Anyway, Sigli Bidley, not important, but he has done some great work. He found out the triple helix model of some kinds of peptides and different kinds of proteins. He found out triple helix model for proteins. So now they found out, oh, proteins bonding can happen in different ways. The hydrogen bond plays extremely important in forming different kinds of biological structures. Now we understand biology. Now we can synthesize materials. Now we can synthesize organs. Everything becomes possible because we understand what is happening. Okay, let me go ahead. Now, Jan Eganhouse, he started thinking, how do the plants make food? What is photosynthesis? How do they make it? Then he understood it's a very complex process. It is not just very simple. There is something called as, there are cubes inside that. There are magnesium cubes inside a leaf, which makes it a beautiful catalyst to form the kind of reactions you can form. And then the photosynthesis was identified. Now, you know, a lot of us in the laboratories are working on making artificial photosynthesis. Can we do the same thing what the plant is doing inside our laboratories? This experiment is called as water splitting experiments, electrochemical water splitting at how to do artificial photosynthesis. Professor Rao has done enormously, has contributed to this photosynthesis. I've also done some small work in this one. I mean, this is artificial photosynthesis. Now we know how to take H2O, the dihydrogen monoxide molecule I talked about, and how to break it, hydrogen and oxygen. See, hydrogen burns, you know, it burns very much. Oxygen, you put water on hydrogen, it will reduce the flame. But hydrogen, when you combine them, they become water. Such a beautiful thing, right? Oxygen, when something is burning, you put more oxygen, it will burn more. So hydrogen on its own burns, and you put oxygen, it burns. But when they combine together in a certain way, it becomes water, with which we douse the fire. Isn't beautiful, Allah? The same hydrogen, the same oxygen, which were helping in burning are now together are giving out a water which stops things from burning. Just it is the distribution of electrons. Electron yell hotu, all hotu, ill hotu, ill bantu, other sala hingat. Right? Such beautiful things are there with simple. You know, you take drug molecules. There is cis and trans in theory. New chemistry. There is one position for one molecule. Let us say a OH molecule sticking on a benzene molecule. Illa cis, illa trans. Okay. I'll tell you, if it is in this position, it is a great medicine. It can cure big diseases. But if it is sitting in this position, it is one of the greatest poisons. Yes, Majala. I mean, look at same material, everything is same, just the bonding, it can make such a big transformation from becoming a useful medicine or a food to becoming a poison. Just because electrons are transferred in a different way in each of these. So beautiful, right? It inspires us, right? We get excited about this. And now, with this water splitting experiment, we are almost about to, there are already cars running with water. You don't need petrol, you don't need solar energy, you don't need nuclear energy, you can run cars. But still, splitting of water is still an expensive way of doing it. So I'm sure when Samatha and Sandhya and everybody become scientists, they will find out ways of making water to run in cars. We don't need to depend on petrol. 100 rupaye get petrol liga. Okay, we don't want, when Samatha and Sandhya become scientists, okay, it will become water. So I think it will be wonderful. You can run planes on it. You can run fighter jets with water. You can run ships, submarines with water. Amazing, right? It is a possibility which will happen soon, my friends. Okay, we are only waiting for Samatha and Sandhya to become scientists. That's it. So now let's go ahead. Okay, look at this. Then there are materials. Then, of course, I don't want to go just because the way electrons are distributed. This picture there are electrons inside and there are roads outside. So electrons also travel in their houses and they don't travel in the roads. We call them as occupied and unoccupied states of electrons. Okay, basically it means is electrons managirtava road na gattirtava. So just that is what it is. When there are roads. Okay, you call it as, when there are a lot of roads, you call it as an insulator. Okay, roads, and I'll tell you about that. And if there are only few roads, you call it as a semiconductor. And if there are no roads, then you stay in the house itself and it's called as a metal. Right? When you look at these houses and roads, the picture is like this. The distance between the house and the road is very large in an insulator, is slightly smaller in a semiconductor. And there is no, okay, so money road dur iddaga, it is an insulator because it's difficult to go from the house to the road. You need a lot of energy. So the band gap is more. So you cannot go from the valence band to the conduction band. And that's why it's an insulator. But when the road is close by, if somebody kicks you, you go to the road. Okay, and that is a semiconductor. Whenever we give an voltage or heat it or beat it or do something, somewhere we kick the electrons, they go to the road, so they become conducting. On their own, they are insulating because they are sitting in the house. But what the kudle, they become conducting, and that's why it becomes an on-off switch. Then you can make a NP, you can make a transistor, you can make a diode, everything, and whole microelectronics with this beautiful thing, right? Just because we know that the band gap is so small that now what the electron will go from their house to the road. Right? And now you have in the top in a conductor, when the road is in the house itself. What happens when the road is in the house itself? Road naga makkonodu, road naga jalaka madodu, ellanu road naga martiri. There is no place to go, right? It's already there. You're already in the road, and they are called as metals. So we call those electrons as free electrons. Okay, they are free to travel inside the metal, but they don't have a place to go. So when I put a light on this, on this insulator, the gap is so much that my light goes through the material. That's why insulators are transparent, right? When I put in a semiconductor, the electrons are kicked out and they go to the road and they become conducting, and some part becomes dark and some we'll look at the semiconductor later. But when you put in a conductor, it reflects back. Yakantandre, because there is no place for the electrons to go. Already they are in the road. So they stay inside the house itself, which is the road itself. That is why the metals becomes mirrors. They're reflecting the light. Okay, so you understand, they reflect because the electrons are far away sleeping in the house, and the light goes through the material, and that's why they are transparent. That is how we make glass. Why is the glass transparent? Because the band gap is large. Why is a metal reflecting? Because there is no band gap in a metal. Why is a semiconductor the way it is? Because it has a small band gap. Means basically the energy required to go from the house to the road is different. If bhal door college ittandre GSS college bhal doote na hogodil bida anta heli mane kudu, that is an insulator. Senate ittandre somebody yaru baid kulle sir attendance hakangilla andkulle, then you jump. When somebody kicks you, you go to the road, you become a semiconductor. But then you are already there in the college doing very well, then bayudiyaka baydidella gets reflected, right? Because you are already good, you're already a sincere student, then it reflects light. So this is what it is, right? So the friends, so these kind of semiconductors were found, were discovered by Volta, and Michael Faraday did the first experiments to show a p-n junction. So these are some beautiful people who could understand all this, could observe different material and try to find out the properties and try to find a reason for that, understand it. Okay, so now let's go. Then we come to nano. Okay, I think sir, inna eshtottu ಮಾಡಬಹುದು? ಇನ್ನೊಂದು 15 minutes I can go on and on. Nagaraj sir, ಸ್ವಲ್ಪ unmute ಮಾಡ್ಕೊರಿ.
Yeah, another 10 minutes, 15 minutes, sir.
10-15 minutes ನಡೀತೈತಿ?
Yeah.
Okay. I'm sorry, I have not scared people away. I don't know how many people are there.
No.
Okay. Okay, right. So I think it is okay. So now there is something more interesting which is coming up, which was something, this fellow, this fellow you can see here, Albert Hibbs, he was a mathematician. He was a close friend of Richard Feynman. They used to sit every day over a glass of beer and discuss many things. Like most scientists sit and discuss over beer or wine, very important for coming out with new ideas. But that's why CNR told me that you cannot become a scientist because I don't drink alcohol. So I said, so I did not become a scientist like him. So if I had a little bit of beer and wine, probably I would have become a scientist, but I could not become. So these people were sitting there and discussing something. Albert Hibbs' grandmother was sick, and the doctor said that surgery has to be done to her. You have to cut and take a tumor out of her stomach. So he felt very sad because he loved his grandmother so much that he said, do I have to torture my grandmother so much to solve her problem? Why are there not tiny surgeons which can swallow like a tablet and they'll go inside and cut the tumor and throw it away? Can't we do it? He's told to Richard Feynman over a couple of glasses of beer. Then Richard Feynman took this point very seriously. Then he's found out, why can't we make small motors, tiny motors? Then, of course, there's a big story. Then there is a very nice lecture he gave, which is called as, very famously known as, there's a lot of room at the bottom. He shows that tiny materials can be made. And then he found out amazing things. And that was the birth of nanotechnology and nanoscience. I'll just briefly tell you about nanotechnology in the next 10 minutes and probably go ahead. And these are some amazing people who thought about nanoscience. One is Feynman, then Taniguchi, who found out about the C60 molecules, and Drexler. Taniguchi did the carbon nanotubes, and Drexler. Of course, there is also, I'll show you later. I mean, there are many other scientists, but I'm just taking a few names here. Drexler was a technologist, and these two were scientists, and they came out with a lot of ideas, thoughts, etc., etc. Okay, now, so you could make machines. Now look at this picture. This looks like an animation, looks like a picture. But people are making devices like this. They are making gears with atoms. Each round thing you see here is a single atom. So there is a possibility that soon we can make machines out of atoms. Right? It's all there now. They're all waiting for Sandhya and Samatha to become scientists. They are the ones who are going to do this. So these beautiful things can be done with this. And now what Feynman said beautifully is, to understand these tiny machines, the tiny robots or the nanobots, which are called, we need to understand quantum mechanics. They don't behave on classical mechanics. They don't listen to Newton's laws of motion. You need something else. Then they showed the importance that at that size, it is like Louis de Broglie found out, they are waves, they are not particles. So now if we put the concept of waves, then we can understand tiny particles. That's what Feynman said, and people started working on it. And then you have Harry Kroto, who discovered the C60 molecule, Tsujima Iijima made the CNT, Andrew Geim, the graphene. Okay, that's beautiful. Okay, these are some beautiful nanomaterials which are done. You see, C60 molecule was the turning point. To find out there is one molecule with 60 carbon atoms, extremely stable and strong, was a great discovery. But ultimately, somebody had to see it, how to see them. And then you had Benningen Rohrer in the bottom, who found out a microscope called a scanning tunneling microscope. With that microscope, I worked 20 years on this microscope, fantastic microscope. You can actually see individual atoms. You see this bottom picture here? This is, you see what these pictures are real pictures, where you put some iron molecules on a nickel surface. You arrange them in circles, in an oval shape, etc. And then when you put them in together, see, you see these waves inside this? These are small waves which are there. They are Schrodinger waves. When you ask your teacher who is teaching Schrodinger waves, sir, Schrodinger waves and they'll say, no, it is an imagination. You cannot see it. It is only a mathematical abstraction. But actually, you can see that electron wave distribution, the distribution of the Schrodinger's equation. You can see that beautifully, which is possible with the scanning tunneling microscope, which is beautiful. Okay. Anyway, again, C.N.R. Rao has contributed enormously to nanoscience and technology. He has about 1,700 research papers. When people said that you cannot make nanomaterials out of this, you cannot make a nanorod out of it, nanoparticle out of it, nanocube out of it, quantum dot out of it, he found very clever chemical ways of finding how to make these materials. And that is how he has contributed. Of course, many people have contributed, but we are so proud that another Indian has contributed so much to the science of this country. And he says, the reason he is able to do some good science is because he understood every word in that book by Linus Pauling, The Chemical Bond, the book called as Chemical Bond. He said that when I was a student, I made sure that I understood. I didn't want to pass exams or anything of that sort. Okay, that is not important for me. I wanted to understand. If it's excited so much for me that how bonds are formed between elements. Okay, and he said that I understood every word on that. And now, because of that, he is able to come with very beautiful ideas into perform different kinds of experiments. And that is what CNR has done for nanomaterials. Okay, so what is the nanomaterial? Okay, it is very simple. Again, I talked about roads and houses for electrons. It is just, there is one electron here, one atom here, which has got 2 electrons revolving around, let us say. So it has got one house where 2 electrons are sitting. Again, I said quantum numbers decide that only 2 can sit in one orbit, because they say that electrons keep telling that I don't want to go with another electron with the same quantum number. So at least one quantum number should be different. Okay, this is called as the Pauli's exclusion principle, right? When you use the Bohr method and the Pauli's exclusion principle, you will know that how many orbits you require for the electrons to go. Then you have these electrons. This is the house of electrons. And whenever there's a house, there's also a road for electrons. This is a road which can carry 2 electrons. Now I add one more atom. So I have 4, 4, 6, 6, like this. I can go on putting different number of atoms. When I make a solid, take an atom and build it, what is called as a bottom-up approach. Okay, bottom-up approach. I can take this, make this material go up and up and up, and ultimately it saturates. When does it saturate, Samata? It saturates when it attains the Avogadro's number. When it saturates, it gets the Avogadro's number. Now it is not called as a particle. Now it is called as a solid or condensed matter. It is called as a condensed matter also. So this region, which was earlier in this region, when it was single atoms, etc., only one atom was there, which was called as atomic physics. We studied it as atomic physics. When it had some more atoms, few atoms together, we called it as molecular physics. So atomic molecular studies. And then we forgot something in between, and we ended up when it saturated, and we call that as solid state physics, right? That was the bulk, study of the bulk. What we had ignored for a long time was this region in between. And that now we call as nanoscience. Where you see here, this, for an atom, this distance was fixed. The house to the road was fixed. For a bulk, it is fixed. But in between, it is not fixed. It varies with size. So the beauty of this concept of when a property changes with size, okay, size in the property change, that I think gave birth to the nanoscience. And nanoscience is a beautiful, you look at this material, it is called as cadmium selenide, it's a semiconductor. If it is here, if it is a bulk, okay, it gives out red light. But when you make it shiny, 2 nanometers particles, it gives out blue light. The same material gives red light, yellow light, green light, blue light by changing the size. And this is the basis of nanoscience. Nanoscience is something where the properties change because of size. It is not about nanometer. That is not important. The size is not important. But the properties have to change. So when does a material become a nanomaterial? Depends on the property with which we are looking. If the property requires it to become at 100 nanometers, it becomes a nanoparticle at 100 nanometers. If the property requires it to become at 5 nanometers, then the particle has to become 5 nanometers to become a nanomaterial. So nanomaterial is not about size, it's about the change of properties. Okay, so this was nanoscience. Again, there are so many things which I'll jump here because of lack of time. And here, look at this friend, Narendra Singh Kapani. You know, we all thought rectilinear propagation of light. Light always travels in a straight line. That is why we cannot see what is happening in our neighbor's house. But sound travels around the walls, so we can hear them. We can hear them fighting, husband and wife fighting, but we cannot see them, right? Because light travels in a straight line. Then this Narendra Singh Kapani, who was working in London at that time, started asking this question, how can I bend light? So now he is called as the man who bent light. He discovered what is called as fiber optics. Now, you know, fiber optics, just like, you know, current is traveled through wires, metal wires. Now we know light can travel through fibers, glass fibers. And this is the beautiful contribution of Narendra Kapani, who is called as the father of fiber optics. His curiosity was, how do I bend light? How do I make light go the way I want it? Then he found out I have to make different kind of wires. And these wires have to be made through glass because light can travel through glass, but it should not go out of the glass. So what I have to do is I have to select the right refractive index. Then I have to clad it outside so that there is total internal reflection. These are some things we all learned. Total internal reflection, transmission of light, we all learned, but he applied that to find out how to make light travel and bend and go the way we want it. And that is fiber optics. Now we know fiber optics is the basis of everything we do with computers, with everything we do with the internet. Amazing. Thousands and thousands of kilometers of fibers are put under the seas, under the oceans. A lot of beautiful things are done because of the fiber optics. Now, this is something very interesting. Okay. Very, very interesting. Samta. Okay. Samta and Shweta madam also. Very interesting. This was a paper which was published in 2018. And the paper, title of the paper says, Death of Death by the year 2045. And this is not a prediction by a guru who will come in the TV morning and tell a planet in bogus. You all know that. Science students, we know that all that predictions, all that is all bogus, right? It's not scientific at all. What these people are, this is a research done by Cordio and Wood. These are the people, one from MIT in USA and the other is from Cambridge from UK. Okay, they worked together to find out this paper, write this paper of death by the year 2045. So that means approximately by 2045, we would have conquered death. Now we understand aging as a disease. If they had known earlier, I would have remained as young and as beautiful as Samata. But now I've become old because people have not yet found out what is aging. But now people know what is aging. It is related to the telomeres. The telomeres will pack the DNA, your biology, you Google all these words, so beautiful things will come. Those decide how our life changes. Why do we age? Why do we become old? Why do we die? Okay, we understand that. Now it is not something which is made in heaven or hell. Okay, we now know that it can be understood here. So nobody decides when we are going to die. We decide when we are going to die. We decide how young we are going to become, right? Nobody else decides this. So it's very important for us to understand such beautiful things are going in science. So friends, okay, now there is an experiment. Okay, I want you to do this experiment in your house. And again, contact me by my email later. I'll give my email ID when you do this experiment. This experiment, you have all done this, but I want to repeat it. Even in lockdown, you can do in your house. There is, of course, okay, take a ball here and just throw it down. You see here, it down, it bounces and falls, right? And if you throw a little bit sideways, it'll go like this, bounce, and it'll fall, right? Now make an observation. Okay, observe all these things. Measure them, right? Curious to understand what it is. Then what you do is you measure so many factors. This is the picture, right? This is the picture of how it goes. This is how a ball goes. Now I want you to measure all this when you have time, and if you want to do it, only if you want to do it, and you plot all these graphs. Plot velocity versus time, speed versus time, displacement versus time, distance versus time, acceleration versus time. They're all different. And you can find so many beautiful graphs in this simple experiment of throwing a ball. Then start thinking, when I throw the ball, throw a different ball, throw a table tennis ball, throw a tennis ball, throw a football. What happens to them? How are they different? Why are they different? The same laws of physics, the same Newton's laws of motion, the same conservation of momentum, the same action and reaction are the ones which work on them. But why do they bounce differently? What are the different factors which influence it? When a ball falls down, the gravity in this direction. When the ball comes up, the gravity is in the opposite direction, right? Then, this is the mass of a ball. It depends on how heavy it is. Then you have something like that. The elasticity of the ball. If it is like a sponge, what happens? If it is hard, what happens? Okay, it is the elasticity of the ball. Then whenever a ball falls, it creates sound. That means some of the energy is lost for the sound also, right? So how do you measure sound in your house? Think about all these things and try to find out what are the different. Then there is an air resistance. There is an air density. So how do you measure air? Without really, are you able to see air? You can see air by your experiments, not by seeing air. So you can do amazing physics by just simple experiment by throwing a ball down and thinking about it. Okay, that is how you can. And see, friends, everything in life is based on these graphs. Science is all about plotting graphs. We all know this is fx is equal to 2. This is fx is x. Okay, this is fx of mod x. Look at the difference when you do modular of x, how the graph looks like. Then f is equal to x square, parabola we know. But x cube, you see, very interestingly, it goes down. Then you have x of root x, which has a certain shape. Then you have cube root of x, which has a different shape. Then the reciprocal 1 by x has a very interesting shape. And then you have a reciprocal 1 upon x square, which also has a different shape. So beautiful, no? And all our observations will fit into these graphs only. If you just understand these many graphs, you can understand any observation on earth, on life. Okay, so if you are a yoga specialist, I'll give you a new kind of yoga. You will look at this picture, right? The same equations here are put in terms of do. This is y is equal to 1. This is yoga. Y is equal to x. Y is equal to minus x. Y is equal to x square, a parabola. And y is equal to x cube. You see, it goes down. Y is equal to modulus of x. Y is equal to minus modulus of x. Okay, y is equal to sine x. You see Bharatanatyam dance, right? And then you have y is equal to e to the power of x. Y is equal to ln x. Y is to e to the power of minus x square. And y x square plus y square is equal to r square is when you do this. Beautiful, right? This is all it is. The idea is we need to understand the relation between our equations and our graphs and our curves. Again, when I was young, I used to go after different kind of curves. Now, when I'm old, now I look at different kinds of curves. And these curves are beautiful, trying to understand. Sir, Hindun pattern, very beautiful mathematics pattern was there. So we need to understand all this beauty comes with mathematics and the physics, the combination of physics and maths. I think that's what I wanted to show you here. And probably even look at sine x. Very interesting. See, let me go back. Okay, see, look at sine x, right? We know sine x, how it comes, etc. Again, I don't want to go, but just tell me, see, this is my sine x, right? This is my sine x, this yellow curve. Now, what is sine of 2x? I'm just changing the inside x by half. So it becomes half of that, right? And now I do sine x by 2. That means I'm making it double. So that means my sine wave will go like this. Very simple. Now I do 4x, 1x, 2x, 3x, sine x. Now I'm only changing the amplitude. I'm not changing the phase. See, such beautiful things, such simple things, right? We didn't understand when we did sine x. Same thing with differentiation and integration. I never understood when I was a student why we do differentiation and integration. Okay, I only by hearted. We all learned everything by heart, and solved all hundreds and thousands of problems and wasted our life. The kind of education is a waste of life. You understand? Because we did not understand such simple things. We didn't know what happens. See, whenever you add something to x, okay, it shifts in the x direction. When you add something to y, it changes in the y action. That's all it is. And we did not understand this when we were being educated. I'm sure your college has better teachers than what I had. So you are doing some wonderful things. You are understanding all these things. But this is what we need to understand, Samatha. This is what we need to understand. What is the relationship? Observations can come as graphs, as plots. And how do we fit an equation for that? Any graph, you can fit equations. And that is what if you learn, you will be bound to become a great scientist, not just a scientist, but a great scientist. I'm learning this in my old age, but you can start learning at your young age. So that is very important. Okay, friends. So to become a student of science, or not to even become a scientist, to become a student of life, you have to first marvel nature. Nature is the greatest thing on this world we should accept. And the beautiful nature, we are so fortunate to be born in this nature. We are so fortunate to see this nature. Forget about our problems in life. Forget about what happens in our love affairs, what happens in your examinations. Forget what happens with your friends, the fight with you had, the food you get or you don't get. Forget about all that. Look at nature. It's so beautiful. And you are fortunate to be born in this nature. And it is your business to understand this nature. As I told you, Einstein said in the beginning, you are so fortunate to see this, that nature is so beautiful, so big, so large, so small. And then you have to emotionally appreciate the size of an atom in the universe. That's why I showed you that video. Emotional connection with that. If somebody asks you what is the size of an atom, if you say 10 to the power of -8 meter, 1 angstrom, sir, then you will pass an examination, but you will not become a scientist. You have to tell, sir, 1 angstrom, sir. You should feel that. What is a light year? So 1 light year, sir. That expression should come in your face. That feeling should come with you. When you attach your feeling with your knowledge, that is when you become a scientist. Okay, it's the emotional connect with the knowledge. So you have emotional quotient attached to the intelligence quotient, right? Is the most important thing. Everybody is intelligent. We know that everybody's brain is the same. Everybody has about 80 billion neurons. So it is only the question how we connect emotions make us a scientist or we don't. So controlling our emotions is more important. The more we know about knowledge, okay, as this balloon is grown, okay, our knowledge becomes bigger and bigger. The balloon becomes bigger. But look at this one interesting thing. The contact of surface area of this balloon with the external world becomes also larger. That means as knowledge grows, ignorance also grows. The more you know, the less you know. That is why there is no end for knowledge. Knowledge is always breeds knowledge, breeds ignorance. And so nothing wrong if you are ignorant. That is a part of life. Nothing wrong if you fail, and that is a part of life. And this is how universe has worked. It is how it goes. And then, so questions begets more questions, right? So these are all the scientists we talked about today. Okay, all these people are the people who ask the small questions with their curiosity driven, and they gave those big answers to this world. So curiosity, imagination creates knowledge, right? So that's what it is, how it is. Now, 10 lessons from Einstein. Einstein says there are 10 lessons you need to learn. One is follow your curiosity. Second, he says perseverance is necessary. Okay, doggedness is necessary. The third, he says focus on the present. Focus. Then he says imagination is powerful. Imagination is important. Then fifth, he says make mistakes. Mistakes ಮಾಡಲಿಲ್ಲ ಅಂತಂದ್ರೆ ನೀವು ಉದ್ಧಾರ ಆಗಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. So make mistakes and be proud of making mistakes. Proud of failing. This is very, very important message I want to give to youngsters. You know, ಒಂದು exam pass ಆಗಲ್ಲ ಅಂತ ಕೂಡ suicide ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತಾರೆ. Yep, please don't do that. You learn from your mistakes. You can become amazing. All the people who have made mistakes are the only people who have achieved in life. Only people who have failed in their life are the only people who have succeeded in life. Please understand this. This is what scientists are all about. And live in the moment. Create value for what you do. Don't do repetitive things. Learn something and do the next thing. Don't be repetitive. Then he says, knowledge comes with experience. Means by doing. It doesn't come by reading. You have to do something to get your knowledge. Then he says, play by the rules. Don't do illegal things. Don't do unethical things. Play by the rules and play better. Okay, that is a sportsman spirit. You know a sportsman spirit? Sportsman in the, he'll fight to win that medal. But ultimately, when he loses to his opponent, he'll go and shake hand with that opponent and tell, I tried very hard to win this prize, but you must have tried harder. That's why you played better than me today. Okay, but I respect you. Great, congratulations. But my friend, don't keep quiet. Next year, I'm coming back and beating you. Right? So you work harder, I challenge you. And that is all about learning. Okay, friends, now we have, as I said, there are two great scientists India has produced. Okay, you know, left side is C.V. Raman and the right side is C.N.R. Rao. Now there is an empty space in between. Whose photo shall we put here? Okay, we were waiting to put some photo here. It should be your photo. Each of you, your photo should be there. Then you can scream, come out of the bathroom and say, Eureka, Eureka. Now we came to Areka, Eureka. Now we have to say, Eureka, Eureka, right? That we understood something. We understood. We think, because we have not become alcoholics. We have not become workaholics. We have become thinkaholics, right? Okay. Thank you all. Thank you very much. Thank you for your patient listening, and thanks for the internet for a lot of pictures I've stolen from the internet. And the internet is an amazing thing, and a lot of things from the internet again, because I've learned from the YouTube. So please let us, our greatest guru, our God to pray is only internet and nothing else. Okay. Thank you all very much. Yeah. Now shall I stop sharing, sir? Okay. How do I stop sharing? How do I stop? Yeah. Okay. Right. Okay, friends. Sorry for boring you for such a long time. Yeah.
No, sir, not at all.
Okay.
Thank you, sir. It was a very informative and inspiring session, which is expressed in very simple and humble way. I'm sure our students have been motivated to develop their scientific temperament. Thank you very much, sir. On behalf of GSS College, we are very grateful to you.
Okay.
Now we have.
I want to just type in my email ID.
Email ID.
Yes,
how
sir.
to do that? Let me see how to. Okay. So I'll type my email ID. This is for students. Okay. Sir, okay. Let me type in this email ID. If somebody wants to get in touch, please, I'll be more than happy to do that. Okay. smsprasad8@gmail.com. Yeah.
Yes.
I'll be happy to get some mails from you. Okay. Thank you.
Yes, sir. So there are a couple of questions. Would you like to take it?
Yes. More than happy to do that. Yeah.
Yes, sir. So
Actually, after asking the question, they will also realize that I also don't know so many things. Yeah, that is very important for students to understand. Master go parangilla anu gottirbeku avrige. That is very important. In fact, master ge ಹೆಚ್ಚಿಗೆ ಬರಂಗಿಲ್ಲ. That is right. Okay. ಬಂದಂಗ ಮಾಡ್ತೇವೆ ಅಷ್ಟ ನಾವು, but ಬರಂಗಿಲ್ಲ ನಮಗೆ actually ಏನು. Right. What are the questions? Yeah.
So these are the questions from students on YouTube.
Yeah.
So one of the book you have mentioned was inspiring book was Cosmos. So they are asking if you can recommend some other good books which can be inspiring.
Whoever is interested, ask them to write a mail. I'll give some very series of books for them so that they can read. Because let the interested people write a mail to me. I'll give them a list of books which they can really read about it. Yeah. Okay.
Yes, sir.
There are many wonderful books. Okay, I've read few of them, and many I've not read also, but I can give a good list. Yeah.
Okay, sir. Thank you, sir.
Yeah.
Sir, one more question is there. How exactly to generate curiosity regarding a particular subject?
ಮಧುಮತಿ ಮೇಡಮ್ ನಿಮ್ ಮನೆಗೆ ಬಂದ್ಬಿಟ್ಟಿವಿ ನಾವೆಲ್ಲರೂ ಮಧುಮತಿ ಮೇಡಮ್ ಬಂದ್ಬಿಟ್ಟು ವಾಲಿ ಸರ್ ಮನೆಗೆ ಬಂದ್ಬಿಟ್ಟು ನಾವು. It's so beautiful, Allah. I can sit here and go into everybody's house. If they only have the courage to switch on the videos, it's nice to go to their house, because they don't call me to their house. So, but this is an opportunity to go into their house, their rooms, their offices, everywhere, right? So very nice. Okay.
Sir, now we'll ಮಾಡ್ಲಿಕತ್ತೀವಿ ಎಲ್ಲ ಮಕ್ಕಳೆಲ್ಲ ಸತ್ಯನಾಶ ಮಾಡ್ಯಾರ ಮನಿ.
Please.
Very good. ಅವ್ರು ಯಾರು ಗದ್ಲ ಸತ್ಯಾನಾಶ ಮಾಡ್ಯಾರಲ್ರಿ ಮೇಡಮ್ ಅವರೆಲ್ಲ ಅದ್ಭುತ ಸೈಂಟಿಸ್ಟ್ ಆಗ್ತಾರೆ ನೋಡ್ರಿ. ಸುಮ್ ಕುಂದ್ರಿ ಅಂತ ಹೇಳ್ಬೇಡ್ರಿ ಅವ್ರಿಗೆ. ಹಂಗ ನಾಶ ಮಾಡ್ಲಿ, ಅವ್ರ ನಾಶ ಎಷ್ಟು ಮಾಡ್ತಾರೋ ಅಷ್ಟು ಅದ್ಭುತ ಸೈಂಟಿಸ್ಟ್ ಆಗ್ತಾರ ಅವ್ರು. ಇಲ್ಲಿಕ್ರ ನಮ್ಮಂಗ ನಿಮ್ಮಂಗ ಹಾಳಾಗಿ ಹೋಗ್ಬಿಡ್ತಾರ ಅವ್ರು. ಓಕೆ. ಸೊ ಅವ್ರಿಗೆ ಗದ್ಲ ಮಾಡಕ್ ಬಿಡ್ರಿ. ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಇಸ್ ಗದ್ಲ ಮಾಡಕ್ ಬಿಡ್ರಿ. ಯಾರು ಗದ್ಲ ಮಾಡ್ತಾರೋ ಅವ್ರು, ಈವನ್ ಅಬೌಟ್ ದ ಕ್ಲಾಸ್ ರೂಮ್ ಐ ಕೀಪ್ ಸೇಯಿಂಗ್ ದ ಸೇಮ್ ಥಿಂಗ್. ಅ ಸೈಲೆಂಟ್ ಕ್ಲಾಸ್ ರೂಮ್ ಈಸ್ ಲೈಕ್ ಅ ಸ್ಮಶಾನ. Right? So let the classrooms become very noisy, but the noise should be about the subject. Okay, only those classrooms are good. So discipline annodaytala is a different definition of discipline. Discipline is not about keeping quiet, right? It is only, we can keep quiet only after we die. Alli mata never keep quiet. Okay, in the classrooms at least there should be a lot of noise. I'm sure Nagaraj sir, Hegde sir will allow you to make a lot of noise, because fish market, yes, it should become a fish market, but it should be about the subject. Barrier, I think that is how wonderful creative things, critical thinking can come out of students. Okay, Shweta, what is the question? I'm sorry. Yeah, okay, tell me.
So the question was how to generate curiosity regarding a particular subject.
That anything, you should want to know more about it. So that's why I keep telling, do something you like. Don't do something because I have to develop a curiosity in this subject. Keep trying so many things. Try that, try this, try this, try this. You will definitely find a place where you will become curious. Hey, a question in you start thinking, why is this? What is this? And that is the subject you love. For examination, you do it and get your marks. That is okay. But find out a place where you actually become curious, because I cannot tell you how to become curious. It is you who has to identify how to become. Curiosity is your individual character. It is not something which can be taught. Okay. Only thing I can tell you, after you become curious, we can guide you how to go about it. Okay, that is Nandu, Hegde Sardu, Pramod Sardu, that is our job, right? We can guide you how to go about it. But what you are curious, you have to identify. So read a lot, see a lot, especially reading and seeing YouTube videos. I recommend to everybody, 1 hour, 1 apple a day keeps the doctor away. 1 hour of YouTube a day will keep all your teachers away, your exam away, everything away, and you will become a scientist. So spend about 1 hour, okay, of YouTubes on the topics you like. It may be science, it may be arts, it may be anything you like. Go after it. Go after it. Yadar one curiosity, you will become fantastic in that. There is no doubt about that. And once you know the curiosity, you have the curiosity, and still you don't know how to proceed, then we are there, old people like us, who will show you the direction. Okay, and please keep writing us, contacting us, all of us. We are all there for you. Okay, and then also write mails to us. Phone madbedri, because I don't pick up my phones, but please write emails to you whenever we get time. We will be able to answer it. And not that I don't want to pick up your phone, because sometimes I don't pick up the phone. You should not think that that is not the intention. Sometimes we are not able to pick up the phone. But if you write an email, sometime when we get time, we will respond to you. Yeah. Okay.
Yeah. Thank you, sir. Rest of the questions, we will mail it to you, sir.
Yeah. Okay. You can ask 1 or 2 more. Any science related questions, I'll be happy to see that. Yeah. If there are some questions, well, at least one question, if you think is interesting, something curious, something different. Yeah. Because I'm sure
one question was there, which you have already answered. What is the difference between science and technology?
Okay. No.
You can elaborate.
Any scientific questions? How many are there approximately in the?
Sir, it is with the technical team. I don't know exactly. They have just given me
later, Shweta, look into it. There will be. I'm sure you identify one amazing question in that. Please send that to me.
Yes, sir.
Please send that
to
me.
Sir.
I'm sure it will be there. Yeah. Okay.
Yes,
Thank
sir.
you.
We'll
Thank
do
you.
that.
Thank you very much.
I request Dr. P.T. Hanamgad, Coordinator, IQAC GSS College, to propose the vote of thanks.
Thank you, Shweta. I have a great pleasure and wonderful it's a wonderful lecture, amazing. Last 2 hours we were sitting hearing Professor Shivprasad sir. In fact, even though he was a busy this thing, he is here with us. He was here with us and have given a wonderful talk. And I think majority of students will start thinking now in line of scientific thinking and to become scientists. Thank you, sir, for sparing your valuable time with us. And I thank all my colleagues and my dear students who have been hearing almost 2 hours 15 minutes non-stop, and wonderful examples of scientists who have created a lot of knowledge. Very informative session, in fact. Thank you once again, sir. and we hope again we'll have you offline in our campus. Definitely.
I'll await the opportunity. Yeah.
Yes, sir. And I thank Dr. Hegde sir for inviting Professor Shivprasad sir and introducing him to our faculty and college, and even for our students. Definitely, it was wonderful opportunity for us also. I thank once again Hegde sir, and I thank all my colleagues who were here hearing Professor. I thank all my dear students, even who were there on YouTube, and I thank all the technical team, Suraj sir and Ajit sir, Shweta, okay, for making this event, even Anuja madam for introducing sir. So making this event a grand success. So once again, I thank one and all being with us and making this session a grand success. Once again, thank you one and all.
I should thank all of you for giving me this opportunity. Thank you very
Thank you,
much.
sir.
Sir, soon we will catch up, maybe sometime in our
Okay.
campus.
Yeah, yeah.
Okay, sir.
Please come. Please visit us. Yeah. Thank you.
Yes, sir. Okay, sir. Thank you.
Okay, sir. Thank you very much.
Thank you.
Thank you.
Thank you.
Namaste.
Thank you, everyone. Have a great day ahead.
So, thank you all.
Thank you. Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Thank you.
सूरज रेकॉर्डिंग ऑटोमॅटिक होते की स्टॉप केल्या जर
टॉप झाल्यानंतर सेव्ह होते सर.
होत आहे ना?
हां, पीसी मध्ये केला ना सर तुम्ही?
होय, पीसी मध्ये.
ओके. ते ऑटोमॅटिक सेव्ह होतं सर.
मग लिव्ह झाल्यावरती होत आहे की ऑन ठेवायला पाहिजे?
लिव्ह झाल्यानंतर होतं सर.
होत आहे ना? ओके. ठीक आहे. थँक यू वन अँड ऑल.
थँक्यू सर.
Thank you. We'll leave them.
या या.
Okay. Bye.